Guys, can you hear my voice?
Yes,
Yes,
sir.
sir.
Hey guys, can you hear me?
Yes, sir.
Okay, so yeah, cool. Welcome to today's class. We are going to discuss projectile motion. Okay. Um, Sorry about the initial delay. Uh, I was trying to set up a few things. I ended up putting in dog ears on myself. Okay, okay, cool. I hope I'm visible as well. Cool, cool. Cool. Guys, you can see my screen, right?
Yes, sir.
Okay, cool. So, okay. So we have done in the previous class, we had done uh, pretty much the basics of scalars and vectors. And if you talk about those quantities, scalars are something that generally have magnitude. Current is sorry. Vectors are something that have both direction as well as magnitude. Now, there are exceptions to this definition, so it is not the final definition. I have talked about this. Vectors are those quantities which have direction, magnitude, and also follow the vector law of addition, if you remember. Okay. Now, give me 1 second. I have been uploading the assignments in hopes you are doing them. Okay. Uh, Please let me know if you're unable to do those questions. You can DM me your doubts. Okay, you can DM me those doubts. And there are two sets of assignments that I'm sending in. One is a subjective based assignment. The other one is pretty much a objective based. So based on this, okay, last class I think we didn't start scalars and vectors, did we?
No, sir, we didn't start it.
Okay. So yeah, quick. I have gone through this uh,
And
in
the
bridge
bridge
course,
course.
in the bridge course though. So I'll have to revise it, okay? Because it was part of bridge course and some of you were not present during the bridge course. So definitely I'll have to revise the scalars and vectors part. It's not a difficult one, but we can do it really quickly, okay? So chapter number 1 was technically over last class because I had completed relative motion in 1D as well. You won't find this topic in your NCRT, in your latest NCRTs. This has been removed, but it's still there in JEE Mains and JEE Advanced, and so we need to do it anyway. Okay. So okay, let's continue. So let's do a little bit of scalars and vectors. Okay. Followed by we'll essentially do projectile motion in a bit. Okay. So if I want to quickly talk about the two quantities that I was talking about, the scalar quantities, please let me know if my screen or what I'm writing is visible to you. I can increase or decrease the thickness of the pen depending on that. So just let me know if it's visible to you guys.
Yes, sir, it's
Okay.
visible.
Okay. So scalars and vector quantities. I have switched from OneNote to PowerPoint because this gives me access to 3D models as well. So in the future, I'd like to use scalars, 3D models in my class lectures. So that's why I switched to PowerPoint. So just testing out right now. So let me know if you face any difficulties. Okay. So scalars and vector quantities, the basic definition of scalars is that generally these quantities will have generally, okay, and this is a very light-hearted definitions of sort because there are exceptions to it. So generally they have only magnitude. Okay, can you think of an exception to this particular statement? I had discussed this in bridge course. What is an exception to this particular definition? Why can't I just say scalars are quantities which have only magnitude?
Area.
No, I didn't quite get you.
Area.
area. What else? Area is actually both scalar as well as vector. Give me one quantity that has direction, but it's always a scalar quantity.
So electric current.
Current.
Correct. Yes. Awesome. So the exception being current essentially pushes us to redefine scalars. Okay, because scalar quantities, if I say they have only magnitude, then what about current? Current has magnitude and direction, but still it's considered under scalar quantity. So what is it? What is the defining difference between scalars and vectors? Well, in vectors, they generally have both direction as well as magnitude. Okay, but the defining trait of a vector is that it follows the vector law of addition. The vector law of addition. Okay, now what is vector law of addition? Let me quickly come to that. Well, if you think about it, like for example, if there is a displacement happening in sorts of, we have done basic different, what can I say? Where is this shape magic tool into shape? Yeah, this. Well, cool. Anyway, so if you have a vector quantity like that and another vector quantity like this, and let's say the angle between them is 90 degrees, let's say this is 3 meters, let's say this is 4 meters. So what would be the distance that the guy traveled? Now this is a scalar quantity, so scalar quantities can be simply added through scalar additions like we have studied. So it's going to be 3 meters plus 4 meters equal to 7 meters. But should I ask you what is 3 meters plus 4 meters in terms of displacement, which is a vector quantity? You would resort to something like this. You're going to say, he said that actual displacement is along this line. Okay, because this is the initial position, this is the final position. And then after that, you can use various, mathematical tools. Like for example, here I can use the Pythagoras theorem. And then I can say this is equals to under root of 3 square plus 4 square, which is essentially 5 meters. So in scalar addition, this 3 meters plus 4 meters is 7 meters. But in vector addition, it's not necessarily 7. It can be 5, it can be 6, it can be 7, it can be -1 also, depending on the angle between 3 meters and 4 meters. Okay, so there is a way to do vector addition. We are going to discuss that next. But you have to understand the defining factor of a vector quantity is that apart from having a direction and magnitude, it also follows the vector law of addition. Now that is not true for current. For example, if 3 amperes worth of current and 4 meter worth of current came in at 90 degrees, the wire which is connected to that is going to have 7 amperes irrespective of what is the angle between 3 amperes and 4 amperes. That's because of conservation of charge. Because if you imagine in 1 second 3 coulomb worth of charge came here, 4 coulomb charge of came on the other side, then from conservation of charge you understand this has to be 7 coulombs. There's otherwise, like, you cannot have an angle, Pythagoras theorem working here and say this is going to be 5 coulombs, because that would violate the conservation of charge principle. So anyway, all of that we'll discuss in due time when we take up current electricity. But basically, vectors, if we have to define, say it has direction and magnitude, which you already do from 9th standard. But you have to be, if you want to be very technically correct, then you have to say it also follows the vector law of addition. Okay. The next question is, how do we essentially represent the vectors? That's the next question we have in our mind. How do you represent the vector? Okay, so the next topic is the representation of vector quantities. Representation of vector quantities. Okay, now how do you represent vector quantities? Well, there are two ways. The first way is to essentially do it in the graphical format. Okay, and the other way is to represent it in what is known as the coordinate format. Okay, the other way is to coordinate. Okay, coordinate. I'm still getting used to this huge screen in front of me. So yeah, handwriting is a bit off. So graphical format and coordinate format. Now, what happens in graphical format? It's essentially you representing the vector in form of an arrow. Okay. So this is generally how you represent vectors in the graphical format. Now in here, let's see, there are two important parts of a vector. One is the magnitude and the other is the direction. Can someone tell me how do you represent, like if you just make an arrow, how do you represent the magnitude in this?
So the length of the arrow.
Awesome. The length of this arrow. So it's not like we're just making one random arrow. The magnitude is represented by the length of that arrow. So the length is also going to play an important role. How do you give the directions? Well, in graphical format, the
So by the
angle in
arrowhead.
arrowhead too it works, but more technically it is represented by this theta. Okay, so direction is usually given by the angle it makes with the either with the horizontal or with the vertical. That's how you give the direction in the graphical format. The arrow is a general, like how do you see, what I want to say is that if you are expressing key, okay, your vector is in a certain direction, arrowhead, you'll have, how do you communicate the direction of arrow? That's impossible. Like if you had to explain it to your friend, okay, where is this arrow, you'll have to probably just do this. Okay, like this is the direction of arrow, this is the direction of arrow. So rather than that, if you say it makes 30° with the horizontal, that's more clear. That's the reason in graphical format, theta is used to represent the direction. I hope that makes sense. Okay. The other is the coordinate form. In coordinate form, you generally write the vector quantity. Like for example, if you want to represent a force, you'll just say 3x cap plus 4y cap. What does this mean? What does this coordinate format mean?
I mean, sir, it represents the vector along the components of x-axis and
Yes.
y-axis.
Yes, well, see, any kind of vector can be represented by the magnitude followed by a unit vector. Now, this what can I say? Let me designate this. This is the vector. This is the vector. This is how you represent the magnitude. This is how you represent the magnitude. And this is known as, this is how you represent a direction. Well, okay, and this is known as the unit vector. This is known as the unit vector. Okay, I hope that is clear. Now in this, what happens is like for example, when you wrote 3x cap, 3 is the magnitude and x cap is the direction. Okay, x cap is essentially a unit vector pointing towards the x-axis. Similarly, y cap is a unit vector that is pointing towards the y-axis. So the combinedly 3x cap plus 4y cap you would mean that a body is experiencing a force which is equals to 3 Newton along the x-axis and 4 Newton along the y-axis. Any kind of vector can be represented like that. And I'm going to show you how to do that. Okay, how do you bring it into component form? This is coordinate form. Also, sometimes it is known as component form. Okay, component or coordinate form. Okay, so I hope this made sense. Now, if you had to write the units at the end of this, you could write like this. This is good. Okay, 3x cap plus 4y cap newtons. Okay, so any doubt in this? This two straight lines at the end is known as the, like when you put it across in math, when you put this two sticks, it becomes the modulus. So it converts negative numbers into positive numbers. In this one, in physics, when you put the two lines in front of a vector, it essentially means you're trying to find out the magnitude of the vector, irrespective of the direction. In vectors, the negative sign actually represents direction. So if you have like 5 Newton and minus 5 Newton x cap, okay, so 5 Newton x cap and minus 5 Newton x cap would generally mean that 5 Newton is in one direction and minus 5 Newton is in the exact opposite direction. Okay, so that being said, let us quickly talk about how do you convert or how do you break into components form. Okay, that's the next topic I want to talk about, breaking into component form or the coordinate form. Okay, now for this again, we have had a very extensive discussion on how to do this. Okay, so let me increase the thickness a little bit. So let's say this is the vector that's given to you. And obviously, if it's given in the graphical format, they will also mention what is the theta it makes with the horizontal. Okay. So if you think about it, if I want to break this vector into two parts, well, one vector will be along the x-axis and the other vector will be along the y-axis. Okay, think of this in terms of displacement. Like imagine if you're allowed to walk only along x and only along y. So to create this particular displacement, you first will have to travel along the x component like here and the y component here. Okay, so I have designated all of this. Now from trigonometry, can you guys tell me what exactly is cos theta? Well, how do you define cos theta? It is base upon hypotenuse. Okay, so base upon hypotenuse in this case will be x by s. Yes or no, guys? Please take 1 minute
Yes,
to understand. If you're not able to understand and unable to cope up with what is going on, please let me know. I'll go a little bit more slower, but I'm going a little bit faster. Why? Because I'm expecting you have already watched this video from learners because it was already done in the bridge course. Okay. But if you're still unable to get this, I'm going to go slow. Just let me know. Okay. So cos theta is essentially base by hypotenuse. So base in this triangle is x and the hypotenuse, let's say, is s. Okay. So from here, if I want to find out what is that x value, it comes out to be s cos theta. Okay, and what it means at the end I'm going to tell. Similarly, how do you define sine theta? Well, sine theta is going to be y by s. So from this equation, if you want to find out y, cross multiply and you get s sine theta. Now this gives us a very important tool, that is how do you break a quantities into circle input and use the button to convert. Okay, so this won't directly work, never mind. So how do you use this particular concept to break into components? Well, imagine you have a block. Imagine you have a block, and this block is applied with, let's say, 10 Newton force in a random direction. Now, doing analysis like this in physics is very difficult if you have your forces in random directions. Okay, that's because 10 Newton, we are more used to x-axis and y-axis. So somehow you want this force to be broken down into its components, one along the x-axis, the other along the y-axis. So let's say if you want to break it into two parts, well, one will be along the x-axis like this. Okay. Well, this angle, by the way, will be given in the question. Most of the time, this angle will be known. So let's call this angle theta right here. Okay. So the component in the horizontal direction is going to be how much? It's going to be s cos theta. For this case, this is going to be 10 cos theta. This is going to be 10 cos theta. Okay. So similarly, the vertical component, guys, will be how much? It's going to be s sine theta, which is essentially 10 sine theta. So all in all, you have to remember this one particular statement. If you ever want to break a vector, let's say this is u vector and let's say this angle here is theta, then the horizontal component or the component across the theta towards the theta is going to be cos theta. So towards theta is cos theta, it becomes u cos theta. And away from theta, like this particular component, away from theta is sine theta. Now you cannot solve the triangle each and every time because you have to do this many times in physics. Okay, so I need you to memorize the process where you see the theta and you know which component is which one. Okay, so I don't want, so this is the basic understanding on how it is done, but I cannot afford that you guys go and make triangles every time you see a force at a random angle. Okay, you have to essentially memorize this. Whenever you have a vector at an angle theta, towards theta component is going to be u cos theta and the other component is going to be u sin theta. Please understand, we have come from like we are able to solve this because it is a right angle. So this component breaking form will only work for rectangular axis systems. So that means your two directions that you're breaking your vector into should be perpendicular to each other. They should be perpendicular to each other. So that is u cos theta and u sin theta. I hope that made sense. Please let me know if it didn't. I'll explain it again. Is it clear, guys, how to break into
yes, sir.
components? Okay, cool. So in this one, if you want to write it in the component form, you'll actually write it like u cos theta x cap plus u sine theta y cap. Awesome. This is how you'll write the u vector right here. Okay. So u vector was initially given in the graphical format with some theta. We broke it into component format. Okay. Please let me know if this makes sense. Okay. Let's move forward then. If everything is okay, I'm going to move forward. Okay, so now that we have understood what is the how essentially do we show the vectors or how do you represent them, the next topic I want to talk about is how do you add the vectors? Like what is how do you add the vectors? Okay, how do you add the vectors? Well, if it's in the component form, like for example, if I give you a vector to be 3x cap plus 4y cap, and I give you b vector to be simply like minus x cap or plus 3y cap, how do you find out a vector plus b vector?
So we add the corresponding components.
Yes, awesome. We just add the vectors, like let the intuition set in, and you will understand ki x and x, if they are in the same direction, I can simply do a scalar addition because they are in the same direction. So I can simply add these two. So that's gonna become 2x cap, and if you add these two, this is going to become 7y cap. So this is how you do addition of vectors if they are in the component form. It's pretty easy if they are in the component form. Similarly, if I ask you how would you do a vector minus b vector, then you generally just do like 3x cap plus 4y cap and then subtract minus x cap plus 3y cap. So if you do this subtraction, you'll get 3 minus minus 1 is essentially 4 and 4 minus 3 is 1. Okay, so you just do it like a normal mathematical process. You just take the x component, add it to x component, take the y component, add it to y component. This is how you do it. Okay, so please let me know if you have any doubt in this. I'm going to explain if you didn't understand this part. Okay. Okay, everybody got this? So that means this is how you do the addition and the subtraction in the component form. It's pretty easy. It's pretty easy in the component form. But should you come across like direct graphical formats, there are two laws that you need to know about adding vectors in the graphical format. The first one is known as the triangular law of addition. The triangular law of addition. Okay. And the other one is known as the parallelogram law of addition. Guys, is my handwriting visible to you,
Yes, sir.
or is it too small? Just let me know if it's too small.
So no
I'll try to.
problem.
Okay. So parallelogram law of addition, guys. Parallelogram law of addition. We have already done triangular law of addition. I don't think I did it in the bridge course. So let's focus on this. See, the triangular law of addition says if you arrange the vectors in a particular format, like for example, if you have like something like this, let's say this is a vector, and you have let's say another vector, let's say that's b vector right there for you. Okay, now the idea is like this, you have to arrange the vectors in such a way, like for example, if you want to do a vector plus b vector, this is what you want to do. You have to arrange a vector, like at the end of a vector, b vector should start. Okay, now there's something called the parallel transposition of vectors, where you can essentially take the vector any place you want in the 2D plane, provided you don't change the direction and the length. Because if you think about it, vectors are all about magnitude and direction. If you don't change any of that, the vectors remains the same, right? So what I need you to do is wherever the value of a vector ends, like it starts from this point and it ends at this arrowhead. So wherever is the a vector ending, from there you start b vector. Now b vector is in this direction, so I'll just have to you know essentially make it like this. This is how b vector represents. Now triangle law of addition says what? It says if you arrange the vector like this, then the third side starting from a vector is going to represent the addition a vector. So if I name it as a c vector, then c vector is essentially the addition of a vector plus b vector. Please let me know if that made sense. Please let me know if that made sense. Okay, so in from that logic, if I ask you something like this, let's say this is A vector, and let's say this is well, let's say this is B vector. How would you find out A vector plus B vector? Can you draw it in your copies and cross check after I do it after a minute? Do A vector plus B vector and tell me how does it look like. I'll also take the attendance. So please respond to your attendance. Ishani,
Yes, sir.
Kartik,
Present, sir.
Namish, Namish, I couldn't hear you. Purva,
Yes, sir.
Ridya,
Present, sir.
Rishi,
Present, sir.
Ritika,
Yes, sir.
Ritu,
Yes, sir.
and there is just Singapore or something. I don't know what it means.
Oh, sorry, sir. That's my other account. I'm sorry. Changed name.
Oh, cool. So Namish, I cannot hear your voice, but I see you are trying to turn on your mic, I believe. So, awesome. So yeah, thank you for the attendance. Let's continue. Yeah, anybody wants to let me know how the resultant vector looks like?
So I think it is an obtuse angle triangle.
Okay, let me draw it. Just let me know if you got the same result. Okay, let me pause the attendance. Give me 1 second. Cool. Okay. So from the logic that we used, well, I'll arrange A vector as usual. See, I'm not changing. These two vectors are parallel. That's what I was talking about. The vectors are actually, you can move it anywhere you want, provided you don't change the direction and the magnitude. So this A vector being of same size as well as being parallel to the original vector. Similarly, B vector, I'll rearrange it in such a way that B vector starts where A vector ends, but it has to be parallel. So probably something like this. Okay, this is how I'm going to represent B vector. Okay. Now, how do I make the resultant? Well, wherever A starts, okay, and B ends, this is going to be the C vector, which represents A vector plus B vector. I hope that makes sense. Okay. In this same particular setup, if I asked you what is A vector minus B vector, can you give me an idea on how to do this? Like, how do I represent A vector minus B vector?
Sir, you would just switch the direction of B vector to the right
Yes.
side.
Instead of treating it like A vector minus B vector, we can treat it like A vector plus of minus B vector. Now we know what minus of B vector means. It means the magnitude is going to remain same, but you have to flip the direction of B vector. So if B vector is like this is what B vector is, you know what? I can copy and paste, right? This is control C, this is control V. So this is B vector. And if I want to, essentially make the reverse of this, is there a way to do that? Rotate. Well, okay, cool. So minus B vector will essentially be like this. Same parallel only, but in the opposite direction. Same length. This is how you would represent minus B vector. Okay. So if I do this again, A vector looks something like this. This is A vector. Minus B vector is essentially like this time. Like this is the reverse of B vector. So this is minus B vector. So how would you represent A vector minus B vector? You start from here and you go up to here. And this is going to represent a D vector, where D vector is essentially A vector minus B vector. I'm just giving different names so as to specify that the vectors that we are coming up with are different. Okay, so A vector minus B vector will be represented using the triangle law like that. Now, I have a question for you. Okay, I have a question for you. What if, what if I give you something like this? Let's say this is A vector. Let's say this is B vector, and C vector is like this. C vector is like this. What can you say about these three vectors? Well, mathematically speaking, like what can you say about A vector, B vector, and C vector? What will you do? How will you solve it?
So the resultant of the three would be 0.
Yeah, that is true. Okay. Because if you use the triangle law of addition, and if you imagine minus C vector, well, this is C vector, minus C vector would look something like this. This is going to be minus C vector, yes or no, guys? So that
So
would
A plus
mean,
B equals minus C.
A vector plus B vector is going to be actually equals to minus C vector. Now, if you take minus C to the other side, you're going to end up with this. A vector plus B vector plus C vector is equals to 0. This is also this is an extension of the triangle law, and it is known as the polygon law of addition. This is polygon law of addition. Okay, and not only triangle, the reason it is called polygon is because if you have any number of sides, let's say 6 sides, okay, so 1 2 3 4 5 6, and if you name them like A vector, B vector, C vector, D vector, E vector, as well as F vector, then again this particular polygon law of addition says ki if you add all of them, A vector plus B vector plus C vector plus D vector plus E vector plus F vector, is going to be 0, because they are starting from the same point and ending at the same point. So if you have a closed polygon such that the arrows are in the same direction, or in the cyclic direction, then the addition of all the vectors are always going to end up and become 0. Okay, so this is known as polygon law of addition. No need to put a different heading for this. This is just an extension of the triangle law of addition. Okay, I hope that made sense.
So is C negative because B is negative? That's why the direction of C was negative.
Can you repeat? I didn't understand.
So C was supposed the arrow head had to be towards A, right? If C was positive.
Yeah, so see, initially the question was given like this. This was the C vector, but I cannot apply the triangle law of addition here because, for C vector to be equal to A vector plus B vector, the arrow had to be in the opposite direction. So instead of taking C vector, I imagined myself the minus C vector. Now this fits our profile perfectly. You start from A, you put the end of B at the start, sorry, you put the start of B at the end of A, and the resultant, the resultant vector that starts from A to the end of B is going to represent A vector plus B vector. So this fits our profile perfectly. That's why I changed it to minus C. Does that clear your doubt?
Yes, sir.
Okay, good. Any other doubts in this? Please ask. Okay, cool. Then let us talk about the next part, which is essentially the parallelogram law of addition. Okay. Now, parallelogram law of addition is essentially a formula that can help us find the addition of two vectors if the angle between them is theta. Now, we already know how to find out the addition of two vectors if the angle between them is 90. Like, for example, if I give you one vector in this direction, the other vector in the other direction, let's say this is A, this is B, and the angle between them, let's say, is 90 degree. How do we find out the resultant? Well, how do we find out A vector plus B vector? Well, you just do under root of A square plus B square. Do you remember this? This is from Pythagoras theorem. I showed you. Like if you go in this direction 3 meters and in this direction 4 meters, they are these two vectors are perpendicular to each other. So if you try to add 3 meters plus 4 meter here, you can do so using the Pythagoras theorem, and you can say the distance traveled is 3 square plus 4 square, okay, which is essentially 5 meters. But if this angle were to be random, like let's say 60 degree, 30 degree, 45 degree, how do you add these vectors? Like if I give you two vectors randomly, like let's say I give you 10 newtons acting in this, 20 newtons acting in this direction, and the angle between them is, let's say, is 60 degree. How do you find out the addition of these vectors? Well, this is where the parallelogram law of addition comes into picture. Okay, it gives you a formula similar to this, and I'm going to derive it in front of you. So let me know if you didn't understand any part of it. Okay. So the process to do parallelogram law of addition is that, for example, this is the base part. Okay. So let's say one vector is given to you. Let's say this is the A vector. Okay. This is the A vector. Let me use small. This is A vector. And let's say this is B vector, which is in that direction, and the angle between them, let's say, is theta. Please understand, I can only use parallelogram law of addition if I have these three quantities, A vector, B vector, and the angle between these two vectors. Okay, so you'll join these two vectors end to end. Starting point of A and B vector should be in the same location, and then the angle between them should be theta. This is how you arrange for the parallelogram law of addition. Step one, the step one in parallelogram law of addition is extend these vectors to form a parallelogram. Okay. Now, how do you do that? Well, A ke parallel, you create another A on the top. Okay. And parallel to B, you create another B on this side. This length is A. Okay. And I'm trying to make it more parallels of sorts. Very nice. This length is going to be B. Okay. And also let's name it. Let's name it A, B, C, D. Please understand, this is the derivation that's going to be useful in your NCRT PT exams. But I don't need you to essentially do it every time you see two vectors at an angle theta. You have to essentially memorize the end result. Okay. But in your CBSE exam, they may ask you this derivation, and also doing the derivation gives you a lot of clarity. So that's the reason we are doing it. Okay. So from here, let's extend this A vector and make a dotted line to the front. Okay. Then the next step is okay. So let me write down the steps as well, so that you can just remember this result. I'm going to use it later on. Okay. So after you extend it, extend A vector and then drop a perpendicular from C. Drop a perpendicular from C. Okay. So if you drop a perpendicular from C, this is what it's going to look like. And let's say this angle here is 90 degree. Let me remove the extra portion here. This angle right here is 90 degree. And let's call this point P. Okay. Step number 3. Understand now, this is what parallelogram law of addition is. It says the longer diagonal, the length of the longer diagonal, represents A vector plus B vector. I hope this makes sense. This is the statement that you have to understand, that the parallelogram law of addition says should you take the two vectors that they are asking you to essentially add and make a parallelogram out of it, the length of the longer diagonal. And what is the length of the longer diagonal in this case? Well, the line joining A to C. This is the vector that is going to represent A vector plus B vector. See, ultimately we are trying to do A vector plus B vector. So also one more thing, I think I should have named this different, because there's AB here, AB there. So just be careful. Small a and small b are representing the vectors. Okay. So if you have two vectors, A vector and B vector, and the angle between them is theta, you extend the parallelogram and the longer diagonal's length is going to represent A vector plus B vector. Now the job of finding out the length of A to C, the job of finding out the length of the longer diagonal is to be done using math. And excuse me. Okay.
I have a doubt.
But for yes.
So in case of a rectangle, it is also a parallelogram, but the diagonals will be equal. So how to choose the longer diagonal?
Well, in that case, choose anyone. If the length are equal, then no issue.
But the
The value,
direction would be
see, the longer diagonal is going to represent, like for example, you're saying like this.
yes, sir.
Oh, okay. So in that one, the diagonal which is running in between is going to be the one that represents A vector plus B vector. Okay. Whenever you have a doubt like that, just imagine displacement. Imagine you went, 4 meters in the x-axis and 3 meters in the y-axis. Where do you reach on this rectangle? Where do you think you will reach? On the opposite side? Like essentially, you went 4
Opposite
meters.
diagonal.
So 4 meters in this direction and then 3 meters in the upward direction. This is where you reach. Okay. So starting point is just that is the final point. So this is the vector that is going to represent the the addition of 3 meters and 4 meters displacement. Does that make sense? Okay. If you have any further doubts,
Yes,
you
I
can
got
ask.
it.
Okay. Next one is what is the fourth step? Well, you're going to use geometry, geometry to find length of the diagonal. Okay, diagonal. This is how you proceed in the parallelogram law of addition. Well, in this one, I'm going to teach you how to do use the the geometry. But before that, think of this CDP right triangle. Okay, just imagine this CDP side triangle separately. So I'll make it here at the bottom. Okay, this let's say is C. This is D. This is P. This length right here, C to D length is actually B. Can you tell me how much is this CP length? You can use trigonometry. One more thing, let me just quickly tell you. If this is theta, this angle will also be theta. Can someone tell me why?
So because AB is parallel to CD.
Corresponding.
Yes, corresponding
Corresponding.
angles because AB and CD are parallel to each other. And and AD acts like a transversal, so that theta is going to be corresponding angles and they are going to be same. So then my question is, what is the length of CP? If you can use trigonometry if you want. This angle right here is theta.
B sin theta.
Yes, awesome. It is actually B sin theta. Okay. What about the length DP?
It will be B cos theta.
Yes, that's going to be B cos theta. If you remember, if you remember this comes from trigonometry. Cos theta is essentially base by hypotenuse. Okay, so cos theta is essentially DP divided by CD in that triangle. So if I plug in the values, this is essentially DP is something that we need to figure out. CD is CD is B. Okay, so when you cross multiply, you will get the length of DP as B cos theta. This is how you do it. Okay, but we have done the component form, so I hope this is already very clear to you. Towards theta is usually, not usually, always, it's always cos theta. So this is going to be B cos theta, and away from theta, this component is going to be how much? B sin theta. Now imagine in triangle, this is how you have to write it. You have to write it, please. Make the triangle separately below. When you're solving for the exams, you cannot skip this. You have to show this. Okay, I'm showing at the bottom, but you have to show it in your fair portions only. Now, in this triangle, in triangle ACP, guys, can I say AC square? Can I say AC square is essentially AP square plus PC square? Well, that's just
Yes, sir.
hypotenuse. That's hypotenuse. Sorry, Pythagoras theorem. Okay, AC square is equals to AP square plus CP square. Okay. Now, what is the length AP though? What is this length AP? Well, that's A vector plus B cos theta. I hope that made sense. Because A to D, this length is A. Here to here, I have already found out to be cos theta. So that means the total length A to P is actually A plus B cos theta ka whole square. And how much is PC? Well, it's B sin theta. B sin theta whole square. Okay. So let me take this stuff a little bit away. Okay. Guys, tell me what is, simplify these two terms and let me know how much is AC. How much is AC? See, this if you open using A plus B whole square, then you'll get A square plus B square cos square theta plus 2AB cos theta plus, don't forget the B square sine square theta, that's at the end, B square sine square theta. Now, one thing you have to know, if I have B square cos square theta and I add it to B square sine square theta, I'm going to end up with only B square. Why? Because sine square theta plus cos square theta is 1. Okay. So if you simplify this, AC square, which is essentially, what was AC? AC is essentially A vector plus B vector. This was from parallelogram law of addition. The length of the longer diagonal does represent the addition. So A vector plus B vector is going to be A square plus B square plus twice AB cos theta. This is a very important formula. I'm giving a little bit time to note this down. Okay. So give me 1 second. Okay. So please let me know. Please let me know if you have any doubt in this. This is the parallelogram law of addition. Okay. I'll summarize on the next slide. Okay. If you have any doubt in this up to this part, please let me know. Okay. So I'm going to take this part to the next slide. Okay. So this is what it is. And this was the initial setup. This was B vector. And this was A vector. And we got the resultant like this. This is how the A vector plus B vector. We sometimes use capital R to represent the addition of A vector plus B vector. And the angle between them, by the way, was given in the question. It was theta. So in all, the result of this particular discussion is that if you want to find out the resultant, the magnitude, especially the magnitude, this is the direction will be given using an angle. But if you want to find out the resultant, all you have to do is take an under root of A square plus B square plus twice AB cos theta. This is the formula you have to use. Okay. So guys, using this formula, quickly do one question that I'm giving you. Okay. Imagine a block is acted upon by two forces. One is, let's say, 10 Newton in the upwards direction, and one is, let's say, 20 Newtons. And the angle between them is 60 degrees. Can you tell me how much is the net force acting on this? Okay. So use this formula to find out the resultant magnitude. Please let me know if you have any difficulty using this one.
Sir, can you repeat the question?
The block is acted upon by two forces. One is 10 Newton, that's vertically upwards, and 20 Newton at an angle of 60 degree with the vertical. So the question is, how much is the addition of these two vectors? 10 Newton plus 20 Newton. Please don't say 30 Newtons because you know these are vector quantities. 10 Newton plus 20 Newton is not 30 Newton. That would have been true if this was a scalar quantity.
So I got the answer as just should I tell it or send it to
Yes,
MS?
sure, you can tell.
So I got it as 10 root 7.
10 root 7, okay. Any other answers? Guys, is everyone getting 10 root 7? Okay, let me do it. Okay, so again, this time again, I have two vectors 10 and 20. Their magnitudes are known. and the angle between them is 60 degrees. So if I want to use the parallelogram law of addition here, I'm going to use the resultant of these two vectors is going to be under root of a square. So 10 square plus b square, which means 20 square, plus 2 times of, I don't think this space is enough. I'm gonna move it you back. Okay, sorry about that. So under root of 10 square plus 20 square plus twice of a, which is 10, into b, which is 20, and cos of angle between them. What is the angle between them? Well, 60 degrees. Now cos 60 is how much, guys? Well, it's half. So when I plug in the values, I'm gonna get 10 square as 100, 20 square as 400, and then this 2 is going to cancel out with cos 60 because cos 60 is half. That cancels out. So you have 200. So your answer is going to be root 700, which is essentially 10 root 7 newtons. Please let me know if this made sense. This is how you do the vector addition if they are given in the graphical format, and the angle between them is given to you as theta, under root of a square plus b square plus twice ab cos theta. Please let me know if you have any doubt in this. If you didn't understand any particular step, just let me know. Okay. Okay. Now, if you were to find out the direction of this, okay, please understand that right now we just know the magnitude of r vector, like the a vector plus b vector ka magnitude we know. We also need to tell what angle it makes with let's say the a vector or b vector. That way you can assign the direction also, because a vector quantity is complete only when you give both its magnitude as well as direction. So magnitude can be easily found out by using that formula under root of a square plus b square plus twice ab cos theta. But should you want to find out the angle between this resultant vector, this is the resultant vector, and the a vector, like this one, this particular angle I'm talking about, this angle, the angle that the resultant makes with the a vector, let's call this angle delta. Okay, so to find out this delta, we can again use triangle. In triangle ACP, tell me how much is tan delta. Well, tan is perpendicular by base, like opposite side by adjacent side. So it's going to be CP divided by AP. Guys, is this correct? Please let me know. Tan delta in triangle ACP, tan delta is going to be the opposite side, which is PC or CP, divided by AP. Please let me know if that makes sense. Okay, now let us plug in the values. CP is essentially B sine theta, and the AP is essentially again A plus B cos theta. Okay, so this, if you solve this equation, you're gonna get the value of tan delta. Okay, if you solve it, you're gonna get the value of tan delta. So that is the idea right there. Okay, and well, right now inverse trigonometry is not taught, but once inverse trigonometry is taught, you'll be able to solve these kind of equations. Okay, but one thing I need you to note about this delta angle is that del is angle with A. Okay, so be careful while using this formula, because this del angle that you are finding out, if you use this formula B sine theta by A plus B cos theta, then del will be the angle with the A vector that you chose. So be careful which angle you are finding. Okay, it's the angle with the A vector. Okay, so please let me know if you had any doubt. That completes the discussion about parallelogram law of addition. Okay, just use these formulas to essentially find out the vectors, the resultant vector and its direction from two given vectors. Please let me know if you have any doubt in this. No doubt?
No doubt, sir.
Okay. Okay, cool then. let's move forward to the next part of the discussion, which is see, there is also product of how do you do multiplication of vectors and how do you do uh, well that's it. Like, how do you do multiplication of vectors? There are two types of multiplication of vectors. One is the dot product, the other is the cross product. But those are distributed when like in chapter number 3 and chapter number 4. So I'm going to discuss them at that time. When chapter number 3 comes in, I'll talk about dot product. When chapter number 4 comes in, I'll start talking about uh, oh sorry, 5, chapter number 5, rotational mechanics, is where I'll start talking about uh, the cross product. Okay, but if you want to learn about them, you should watch the learners videos uploaded. Okay, in the NEET section, especially the prerequisites for JEE and NEET. There you'll find my videos about the parallelogram law of addition, the products. Like, I've taken one full lecture only on vector quantity, scalars and vectors. So that's 3.5 hour lectures of scalars and vectors. So there I have explained everything in great detail. Okay. However, this much is enough right now for this particular chapter to be over. And after that, whenever I come across the quantities where we need dot product, I'll explain dot product one more time. Then after that, I'll talk about cross product. But if you want to get an overall idea of scalars and vectors, you should watch that video from the next. Okay, I will upload the link today. If you want, you can watch that. I think I had uploaded that video in the previous class as well. Uh, like, you could watch that video.
Yes, sir, you told us to.
Yes. Now, next topic that I want to talk about is essentially projectile motion. Okay. So, and obviously the chemistry test tubes, because we are. I don't know why I chose this. Now I just realized this is just representing chemistry. Well, no issues. Next time. Next time. Okay. So, what exactly is projectile motion? Anyone has any idea? Let me get myself some water. Till then, please let me know what do you understand by projectile motion. If you have done that in class or something like that. I don't want to pick names. Don't force me to pick names, guys. Voluntarily
Sir,
say.
projectile motion is like the path followed by a body when it's shot at a specific angle from the ground.
Well, perfect. That's what projectile means. Like, for example, if you are, well, let me just show you a
So
few
like
things.
the motion of a javelin throw.
Yes, awesome. That's perfect. That's what it means.
Or
Okay, so
a
let me
cricket ball.
cricket ball as well. So all of these are actual real life mm, projectile motions. Okay, give me 1 second. I want to show a GIF of that. Ooh. Well, my internet sucks today. I don't know what's going on. Okay, sorry about the delay, guys. So, projectile, what exactly is projectile? Okay, so when you throw something upwards, it just goes up and comes back to the same spot. Okay, but should you throw it at an angle, it's not going to come back to your hand and it's going to go in a certain, it's going to reach some horizontal distance. Okay, so when you do that, the thing that you throw is known as projectile. Okay, and the angle that you throw it with. Okay, so let's say this is the ground and this is the initial velocity of launch. Okay, so these things have names, so let me write down the names for you guys. So let's say this is the projectile motion that happened. The path is known as trajectory, which is already written on the left side. You can see that thing is that the path that the small projectile follows is known as the trajectory. It's known as the trajectory. Okay, well, the initial velocity with which it was thrown is known as the initial launch velocity. This is known as the initial launch velocity. Okay. The angle at which it was thrown with respect to the horizontal. Okay. This angle has to be with the horizontal. That angle is known as projectile angle. This is known as the projectile angle. Okay. What else? Well, this projectile is going to displace something along the x direction. X direction means the horizontal direction. When you throw the projectile, it's going to reach certain distance along the horizontal direction or along the x-axis. That distance is actually known as range. Let me color code this. R is range. Okay. And what exactly is range? Well, the distance of its starting point to where it landed along the horizontal axis is known as range. Please understand, range is not equal to the length of the path that the body traveled. Okay, see, if you think about it, the body has traveled like this is how it has traveled. It has traveled like this. That is going to be the actual length of travel. But range is not that. Range is essentially in horizontal direction. How much distance did your body cover? How much distance did your projectile cover is known as range. Okay. One more thing that we need to know about this particular projectile is at a certain at this mid range. Okay, at this mid range, the body is going to reach a maximum height. Okay, from the ground. From the ground, it's going to reach a maximum height, after which it starts falling down again. So it goes up in the beginning, it reaches a maximum height, and then it starts falling back to earth. That height is known as H max. Okay, H max. This is the maximum height. This is the maximum height. I think it's HEI of the projectile. Okay, guys. So these are the things that you need to know about uh, the projectile motion. What are the different names? Well, when you launch something with a certain velocity, it will have an initial launch velocity of the projectile. Okay. Next thing, which is very vital, is the angle at which you give your launch velocity, and that will be called the projectile angle. Okay. R is going to be the range, which is essentially how much far did it reach in the horizontal direction. That is going to be known as the range. Okay. Also, during the projectile motion, the body keeps on going up, and after a certain height, it starts falling down. The maximum height it reaches is known as H max. I hope you have noted this down. These are the basic quantities that you need to know about the projectile motion. Okay. Now, you need to understand a few things here. Okay, if you ever come across a situation where they gave you a projectile and you need to solve it, there are few steps that you need to understand regarding solving projectile motion. No matter, see, the case that I'm going to take up in the beginning is the most basic case, which will help you only at the CBSE level or your NCRT levels. Should you want to go into the depth of things and you want to essentially understand how uh, sort of how can I say? Like, if you want to go into the competitive level, they will never ask you formula-based questions. We'll derive some formulas. We can find out essentially how much is the range, how much is the maximum height. All of this we can find out using a formula. But if you get a question from projectile in competitive exams or in advanced physics, they will never ask you formula-based question. They will check whether you understood the process of deriving it or not. So formulas in this particular setup is not gonna be of any importance. What is more important is how do you get to those formulas of the projectile motion. Okay. So to understand that, I'm gonna take up the next part where I'm going to write down the steps on the right hand side. What are the steps I'm following to find out the projectile motion? Okay. So the first thing that you'll notice is that the projectile motion is in true definition 2D motion. We have studied 1D motion where body is traveling only along the x-axis. It's only traveling along the x-axis. But this is the first case when the body is not traveling in a straight line. It's traveling in a curved path where you can imagine the body to be traveling somewhere between x and y. So it has motion both in x-axis and both in y-axis. And this is the single most important sentence that I'm going to say in the next few seconds, which is going to help you solve projectile. It is that you can treat the motion in x and y axis independently. What does it mean? It means my step one of solving a projectile will be independently figure out the components along x-axis and y-axis. In brackets, you can write down the parameters that we are looking at are, well, initial velocity, displacement, comma, write down comma displacement, comma, well, the last one is acceleration. Okay, this is the step one of the projectile motion. To analyze the projectile motion, you need to first essentially figure out the parameters in x and y axis completely separately. Okay, completely separately. That sounds really nice. Okay, so you know what, I'm gonna need a little bit of magic tools to do this one, so because this is kind of important. So I think like this and like this. Good work. It's working. Very nice. Well, one more. Oopsie. There you go. Can we make this one straight? Very nice. Okay, so these are x and y axis that I'm going to work with. This is essentially x axis. This is y axis. Okay, so the projectile is going to be launched from here with an initial velocity of, let's say, u, and the angle that it makes with the horizontal. So you should, I'm going to throw it more steeper like this. This is u, and the angle between here is theta. So the path that it follows is going to it's going to look like this. I'm going to try my best to do this properly. Yes, this is how the projectile is going to look like. Okay. So what is step one? Okay, independently figure out the components of x and y axis. Okay, and the parameters we are looking at are displacement, initial velocity, and acceleration. I have told this in vectors also. Just now I taught you vectors, and I told you doing an analysis on this is very, very difficult if it's at a random angle. So what I need to do is I need to figure out that what is the initial velocity in the x-axis, okay, and what is the initial velocity in the y-axis. Okay, so let me make this table here. I'm going to figure out what is the initial velocity, What is the initial velocity along the x-axis first and then along the y-axis? Okay. So guys, how do you break this into components? Tell me. Tell me, how do you break it into components? I'm
So
gonna do it with
using
the,
trigonometry, so along x-axis, it would be u cos theta.
yes, awesome. You gotta remember this along theta. If you want to try to figure out the component along the theta, this along the x-axis, this component is going to be how much, guys? It's going to be u cos theta. Towards theta, cos theta. Now, if you want to figure out what is the component along the vertical direction, can someone tell me what is the component along the vertical direction? U sine theta is going to be u sine theta. Towards theta is cos theta. Away from theta is sine theta. You can figure all of this out using the what? Trigonometry process. Okay, so all of this is coming from trigonometry, guys. This is coming from trigonometry. So I'm gonna tabulate them. So in the vertical direction, which is the y-axis, the initial velocity is u sine theta. Whereas in the horizontal direction, the initial velocity is u cos theta, guys. It's going to be u cos theta. Very nice. First part is done. Please let me know if you have any difficulty in understanding this. I'm going to repeat one more time if you didn't understand. Please let me know if you didn't understand any part of this. That was step number one, first part. I have already decided what is x-axis ka initial velocity, what is the y-axis ka initial velocity. Doubts, guys? Doubts? Ask me doubts. No doubts?
No doubt, sir.
Understood. Okay, cool. Let's move ahead. Then let's talk about what is the displacement along the x-axis. What is the displacement along the x-axis? Well, the body starts from here and it ends at this location. In x-axis, what is this displacement? What is this displacement, guys?
That's the range.
It's the range. So I'm going to write down here what? Range. The range. Well, can you tell me in the y-axis how much is the displacement?
That's the maximum.
H max.
No. See, the body, if you think about in y-axis, the
So it will
body
be zero
went,
at the end.
it went up to H max, but it also came down at the end to the same location, right? Does that make sense, guys? Along the y-axis, if you think, the body went up to a certain elevation and then reached the same elevation again. So what is the displacement along the y-axis? It's going to be zero. It's not going to be x max. Why? Because we're not talking about distance traveled. We are asking displacement. Yeah, I agree with you when you say ki haan, it's at the mid of this projectile, during the half of this projectile, this body was displaced to h max. Yes, I agree with that. But after that, it came down again to the same height, right? It came down to the same height, making the displacement along the y-axis as zero. Y-axis as zero. Please don't say r, because r is the displacement along the x-axis. It traveled r distance in the horizontal direction, but along the vertical direction, it started from the same elevation, ended up in the same elevation. So the y-axis displacement is going to be zero. Now let's talk about acceleration. That's the final thing I want to talk about. What about acceleration? Is there an acceleration along the x-axis? Is there an acceleration along the x-axis? First question.
So if we
Yeah.
ignore air resistance, then nothing.
No. Yes. There is no acceleration along the x-axis because there is no force along the x-axis. See, whenever we are doing the projectile motion in the beginning, we are going to ignore any air resistance or what those are complicated topics that you will study in your engineering. Right now, there is no resistance, ideal conditions. Okay, so the only acceleration that is acting is actually gravity in the downward direction, and that is equals to minus 10 meter per second square. Yes or no, guys? Yes. So that means I'm going to plug in what? Y-axis as minus g. Please let me know if this made sense. The acceleration along the y-axis is going to be minus g. Let me know, guys. Any
Got it,
doubt
sir.
in this? This is what we did in step number one. The step number one done. Okay. Do you want to know step number two? Well, okay. Let's go to step number 2. Step number 2 is use equations of motion. Use equations of motion. Okay. So when you use equations of motion, you're gonna use it only along one direction, right? Okay. So, well, before that, I want to quickly talk about this one thing. Okay. See, here in x and y axis, all the quantities are different. Initial velocity in x axis is different compared to y axis. Displacement is also different. Acceleration is also different. But there is one quantity in physics that does not depend on the frame of reference. Can you tell me what parameter is that? I've talked about this in last class when I was talking about relative velocity.
The
Time.
time.
Yes. See, it doesn't really matter if you're looking at the ball along the x-axis or along the y-axis. If you're looking at the projectile along the x-axis or y-axis, the time that you find from both these axes should be the same. Again, let me repeat one more time. See, in relative velocity also, I've talked about it. If you measure the time from a bus which is moving at 10 meter per second, it's gonna be the same time when you measure it along the ground. So it's not dependent on the reference frame. From the reference frame point of view, everything else can change. Like if you are on a moving truck, you will see the velocity is different. You'll see the displacement is different. You'll see even the accelerations to be different for different bodies. Okay, but what does not change is time. Time is the ultimate constant in classical physics. Okay, so here what we are going to do after we use the equations of motion, time, after using the and equate time. Okay, so please understand that time along x-axis and the time along y-axis are going to be exactly same. They're going to be exactly same. So if you find out time from the y-axis or the x-axis, after that, uh, you can use that time to essentially tell that is the time of the flight of the entire projectile motion. So if you find out the time from the y-axis also, this is going to be the same time that the ball took in covering this entire projectile. Okay, along the x also is going to take the same time, along y is also is going to the same time, along this projectile path also is going to take the same time. Okay, so I hope that made sense. Now I'm going to do that, whatever the step that I have written, I'm going to do it in front of you. I have these quantities in y-axis. Okay, sorry, I have these quantities in y-axis. I'm going to use these y-axis quantities to essentially find out the time. Okay, so I have these quantities with me, guys. Which equation of motion do you think I can use to find out the time? I have initial velocity, I have displacement, and I have acceleration. So which equation do you think I can use? I can use S
The
equals
second
to
one.
U
S
plus
equals
half.
half AT square. Okay, now plugging in the values. Initial velocity is u sine theta, displacement is 0. So 0 is equals to, how much is displacement? Oh, sorry, how much is initial velocity? Well, u sine theta into t. Okay, and how much is acceleration? Well, minus g, half into minus g t square. I need you guys to find out time from this. How much time you're getting? This is not one of the roots will be 0, so one t will cancel out. You can find out the value of time. One t is going to cancel out. Tell me what is the value of time.
Sir, gt square by 2u sine theta.
No,
Oh, wait.
time. Find out time. Take your time in finding out time. Give me the correct time. It's about
It will
time,
be
guys.
2u sine theta by g.
Yes, 2u sine theta by g. That is absolutely correct. You take the other term minus half gt square to the other side. One of the t's gets cancelled. 2 cross multiply and g divide. So your time comes out to be 2u sine theta by g. This is known as the time of flight. The time of flight of the projectile is essentially 2u sine theta by g. 2u sine theta by g. Remember, we have already taken sign convention into consideration. because gravity is acting downwards, I have taken it minus. When you're using this formula, you just have to take the magnitude of gravitation. You don't have to find out the value, like you don't have to use the minus sign. Okay. Please let me know if you have any doubt in the time of flight derivation. I have used y-axis quantities to essentially figure out what is the time. But I have also told you that time is not dependent. It's not dependent on what? It's not dependent on the reference frame. So if you find it along the x-axis or if you find it along the y-axis, it's going to be same in all the different perspectives, x-axis, y-axis, or even the 2D format where I'm seeing the entire projectile. Okay, please let me know if you have any doubt in this. I'm going to explain.
Sir, how
This
do you
is,
get 2u sine theta by g?
well, I am going to show you here. Okay, let's do this step. Guys, let me know what happens if it comes to the other side. It's going to become what? G by 2t square. Do you agree with me? I took this term. See, 0 equals to this plus this. Oh, sorry, minus this. It's not 9, this is G. Okay, so when this particular term comes to the other side, this becomes gt square by 2. Now, one of the time gets cancelled out and time becomes equals to cross multiply 2u sine theta by g. Does that clear your doubt?
Yes, sir.
Okay, so that's a time of flight, guys. Please let me know any other doubts, guys. Guys, any other doubt? No, sir. Okay, good. Now let's continue. Let's continue. We have found out the essentially the time of this. Now let's figure out what is the range. Okay. So for range, I'm going to need the x-axis quantities. So these are the x-axis quantities. I'm going to take them to my next page here. These are the x-axis quantities. Okay, so control C. Sorry. Okay. These are the x-axis quantities that I have with me. Using these x-axis quantities, can I find out the value of the range? Now, again, understand, I also know the time now. Time we just found out using the y-axis, but time does not depend on reference frame. So time I know is, well, 2u sine theta by g. 2u sine theta by g. So is there a way to find out the range this time? Well, again, I can use the same equation, s equals to ut plus half at square, but there is no acceleration, so s is simply equals to u into t. Okay. Yes, guys, please let me know if you have any doubt in this. So displacement
doubt.
will be simply the velocity into time. So velocity is how much, guys? Velocity is u cos theta in the x-axis. I'm solving this for the x-axis, remember. U cos theta. And time is how much, guys? It is equals to 2u sine theta by g. Okay. So if I simplify this, this is going to be u square because there are two u's and u's. And then it's going to be 2 sine theta cos theta by g. This is the definition of range. This is how you find out range. U square 2 sine theta cos theta by g. Please let me know if you have any doubts here. Guys, let me know if you have any doubt. No doubts?
No, sir.
Okay. What everybody
So
is
we can
able.
simplify it as 2 sine theta cos theta as sine theta.
Yes, we can. Okay. But before we do, I want to talk two important facts about this range. I want to talk about two important facts about this range. For the first fact, I need the formula to be like this only. Okay, there is a trigonometric identity. That's what he is talking about. I'll explain it. But before that, what I need you to do is, okay, so I found out the range formula to be essentially r equals to u square 2 sine theta cos theta by g. This is for an angle theta. Okay, this is for an angle theta. Guys, find out the range. Find the range for if the angle becomes equals to 90 minus theta. What will be the range if the angle is 90 minus theta? Well, you're going to write the same formula. Well, range is equals to u square 2 of sine 90 minus theta and cos 90 minus theta by g. Well, how much is sine 90 minus theta, guys?
Sir, it will
Cos
become
theta.
the same because cos
Cos
theta and sin
and
theta.
cos 90 minus theta is sine theta. So you're correct. You're saying, sir, the range became the same. This is what the fact is. If you have complementary angles, theta comma 90 minus theta, these two angles will always have the same range value. So give me some examples, like for example, 30 degrees and 60 degrees. If you launch at the same velocities at 30 degrees and 60 degrees, the range is going to come out to be the same. It's going to come out to be the same. See, they're going to take different times. Why? Because the time is 2u sine theta by g. This is the time of flight. Well, depending on the sine theta, the time will be different. So 30 degrees and 60 degrees will take different time to reach, but they are going to reach the same spot. Okay. Now, again, I have a visual representation for this. Give me 2 seconds to bring it out to you. Okay. Uh, this is what I was talking about. Just check this out. Check the blue projectile. Check the blue projectile and the green projectile. Okay. They have the same essentially range. Okay. But the guy is throwing only at 45 degree. I think I have a better one. Oh, sorry. Let me see if I can pull this up. Okay. Let me change the screen that I'm sharing. Just let me know if you are able to see. Guys, can you see the new screen?
Yes, sir.
Okay. Now look at this. I'm going to have like this is depending on the things. Okay, never mind. I don't need the numbers. So depending on the tick mark here, I can select whether I want the same max height, same range, but I want same initial speed at this point. So I want the same initial speed, and I'm going to fire a few projectiles at different angles. Okay. So notice the timings as well. So just look at it once. I'm going to repeat it. Okay, so let me repeat it one more time. I need you to tell me some observations that you see from here. Tell me some observations from this. Yes, tell me. Talk to me, guys. It's not a single-sided teaching.
Sir.
Yes,
30 and 60 degree meets in the x-axis.
yes. 30 degrees and 60 degrees are essentially meeting at the same point on the x-axis. That's very nice. What else? Do 60 degree and 30 degree have similar times? Do they reach the
No,
same
sir.
spot at the same time? Let me repeat. Reset
They
and
have
fire.
different times and the height also.
Yes, they have different maximum heights and they have different timings to reach that range. Okay, but the range ultimately is going to be same for 30 degrees and 60 degrees. Okay, now there is this one angle for which the range is maximum. Like for example, let's say you want your, like you said, cricket, right? Like if you want to reach the maximum sort of range, what angle should you hit the ball at? Well, 45 degrees. See, what I'm saying is if the initial velocity of the ball is fixed and you throw the projectile at different angles, if you throw it at very less angle, what happens is it just makes a very small, like 20-degree one, it makes a very small projectile. Before it's able to reach very high, it falls to the ground. Okay. If your angle is very high, like imagine 89 degrees, 89 degrees projectile will just go too far up and it's just gonna land really close to you. Okay, so the maximum range is achieved at what angle, guys? Exactly in between, which is where 45 degrees. And we can also talk about this like using math here. Okay, 45 degree is the furthest down range, we can talk about it by converting that formula into what our friend there was saying in a bit. So this was the range. I'm going to copy this. Okay, this was the range, and there is this identity that says ki 2 sine theta cos theta is actually sine 2 theta. How many of you have already got it? Is everyone aware of this trigonometric identity, or do I need to explain? If I need to explain, please let me know. Okay. So using this trigonometric identity, range can be written as the range R. I'll use the symbol R to represent this as u square sine 2 theta by g. Sine 2 theta by g. Okay. Now this makes it. Yes.
Explain sine to theta.
I didn't understand. Can you repeat your question?
Can you explain the sine to theta part?
Yeah, sure. See, it's a trigonometric identity like sine square plus cos square equal to 1. So what I can do is verify this in front of you. I think your math teacher will be better suited in explaining where it came from. Okay. So let's just test it out whether this statement is true or not. So 2 sine theta cos theta is supposed to be equal to sine 2 theta. So let's check it out for 30 degrees. So if theta is equals to 30 degrees, 2 times of sine 30 is how much, guys? Sine 30 into cos 30. I'm just gonna verify it in front of you. I'm not gonna explain how it comes. It's a long process. Okay. So sine 30 is half. Cos 30 is root 3 by 2. So 2 and 2 cancels. You get root 3 by 2. Sine 2 theta is essentially sine of 2 times 30 degrees, which is how much? Sine 60 degrees, which is how much? Root 3 by 2. Okay. So this is just to give you an idea of what exactly I'm talking about. Okay, if you have 2 times of sine theta and cos theta, it will be equal to sine of that double angle. This is known as double angle. So some people find it difficult to understand what exactly is going on, but this is an identity. Just like sine square theta plus cos square theta is equals to 1, 2 times sine theta cos theta is actually sine 2 theta. There are other identities as well. Sine theta, sine A plus sine B is essentially, do you remember? Like there are other identities that you're supposed to get by now. Sine A plus B is how much, guys?
Sine A
That'll be
sine B plus cos A cos B.
No,
that'll be
sine
sin
A
A cos B
cos
plus
B
cos A
plus
sin B.
cos A
Sorry,
sine B.
my bad.
Okay. And there is also like what you the formula that you were talking about is this. Cos A minus B is actually cos A cos B
Yes, sir.
plus
Sorry.
plus sine A sine B, right? This be careful. These are the formulas you have to. There are also triple angle formulas. Sine of 3A is actually 3 sine A minus
Minus 4 sin cube A.
Yes, 4 sine cube A. So remember, there are different identities that you're supposed to come across at this time. If you haven't, that means wait for a bit. You will come across these identities very, very soon. So, however, this is also one of those identities. I'm just giving you a list of things that you need to be aware of. Take a screenshot if you have to. Okay. These are the quantities. These are the trigonometric identities that you're going to come across very soon. They are always true. Okay, you're going to need them slightly. Sometimes in physics, these are the quantities. These are the trigonometric identities that you need to know for physics at least. Okay. There are many more. I especially hate the trigonometry part for this reason. There are a lot of identities that you can, memorize and then forget very easily if not used. Like if you use it daily, then yeah, you'll remember, as many as you get. But after you don't use it for a while, you tend to forget. Okay, so that's precisely why I don't like trigonometry. I don't like it. Okay, so u square sine 2 theta by g. Back to this. Well, do you know sine 2 theta's values? Like sine theta's value is actually limited. It has a maximum value and a minimum value. Can you tell me what is the maximum value of sine theta, minimum value of sine theta?
So the range is from -1 to +1.
Yes, the sine theta's maximum value is +1. It cannot go beyond that. You won't find sine theta equals to 2. That's an invalid equation. Okay, you can have no angle inside sine theta where any kind of theta is not going to give you 2. It's going to give you maximum 1, and that angle comes when what is that angle for which you get 1?
When it's at 90 degrees.
90 degrees. Sine 90 is 1. Okay, So if you want your range to be maximum, you want sine 2 theta to be maximum. Yes, because u square by g is so fixed because I told you for the same initial velocity. So u is a constant, g is a constant. If you want to maximize the range, sine theta needs to be maximum. So that means this angle right here, 2 theta, needs to be 90 degrees. This is where you get this idea that theta is equals to 45 degrees. This is how you show that your maximum range is achieved at 45 degrees. Please let me know if that made sense. So I hope if you have any doubt, I need you to ask me right now. Ask me. No? No doubts at all?
No, sir.
Okay. Cool. Let's move forward. Find out the last thing. We have already discussed the time of flight. The time of flight is 2u sine theta by g. The range is u square 2 sine theta cos theta by g. And the last one I want to talk about is the h max. Do you remember we have to also find out the h max? Okay, so let me copy this stuff from here. Control C, and this is Control V. Okay, so this is what we have found out. Okay, see, to find out the maximum height right here, obviously I have to do the analysis along the y-axis because h max is achieved along the y-axis. So y-axis quantities that I have with me right now is, I know the initial velocity is u sine theta, okay, written in green right here. Displacement is what we are looking at, h max, okay, h max is the displacement. Acceleration is minus g. Time is u sine theta by g. Can someone tell me why didn't I take 2u sine theta by g? Why did I take u sine theta by g?
So because 2u sine theta is when it returns back. We are interested only for half the time when it's at the maximum height.
Awesome. Okay. 2u sine theta is the time it takes for the ball to go up, reach h max and come back. So h max will be given in u sine theta. Also, one more thing I want to know. What is the final velocity along the y-axis at the highest point?
So 0.
Guys, do you get it? See, if you throw a ball in the upward direction, it's gonna go and momentarily stop and then it's gonna return back. If you're talking about this projectile motion only along the y-axis, see, at the highest point, it's not that the body is at rest. It will have a horizontal velocity. Definitely, it's gonna have a horizontal velocity. But velocity in the vertical direction is going to become zero. It's going to become zero. Okay. So final velocity is going to be zero. Initial velocity is u sine theta. I also have the distance and I also have the acceleration. I also have the time. Which equation do you want to use? I can use both. I can use s equals to ut plus half at square. I can also use v square minus u square is equals to 2as. I think I prefer this one because I have a 0 in this. So 0 square minus u square sine square theta is equals to minus 2g into h max. So from here, you get the value of h max to be how much, guys? How much do you get? U square sine square theta by 2 times of g. Please let me know if this makes sense. Please let me know if you have any doubts in this. If you have any doubt in this, please ask. This is how you find out the maximum height of a projectile. Okay. Again, pretty simple. See, consistently I've been doing this. What I separate out x-axis and y-axis completely differently. Okay. And essentially, after I completely separate it out, then you treat all the parameters like completely differently. So y components are different, x components are different. But one thing that you are relying on is the time. The time is not going to change along the x-axis or y-axis. Along the x-axis also the time is going to be same. Y-axis also is going to be the same. So if you have any doubt in this, please ask. Okay. And if you don't have any doubt, let's quickly do one simple question. Okay. Imagine that I send out a projectile. I send out a projectile. Try to make a rocket here. By the way, it's not valid for a rocket, but still, just for the sake of it. And why it's not valid, I'll explain in a bit when we talk about the assumptions we took. Okay. So let's say ki the initial velocity of this rocket is, this is not a rocket, it's not thrusted, it's essentially just like a bullet. See, when you say rocket, it will also have a horizontal acceleration. I should not make rockets here. Rockets have a thrust that pushes the rocket forward in the horizontal direction. That is not there in this. This is essentially a simple, uh, like if I had to think about an object, real life object, it would be a cannonball. Cannonball will essentially start with the initial velocity, but it does not have a thrust. Okay, it does not have afterburners. So you have a cannonball with initial velocity, let's say, is 30 meter per second. Okay, and it is launched at an angle of 30 degrees. 30 degrees. I need you to find out how much is the time of flight. Find out how much is the time of flight. Find out how much is the range. Also find out how much is the H max. Find out how much is the H max. And while doing so, I need you to do it. Don't use the final formulas. Okay, I need you to do it. This is the first question if you're doing from projectile, right? So I need you to take your time and do it like the derivation. Okay, don't do it using the direct final formulas that I have derived. Okay, use it like, break it into components, take the x component separately, y component separately, find out the time, find out the h max, find out the range from understanding how it's done rather than directly using the formulas. Okay, so do that, and after that take a take a little bit of break, and then I'm gonna meet you back at 5 minutes to do the question, and then that's 10:55, and then after that 15 minutes break. So I'm gonna meet you at 11:20. Okay, I'm gonna meet you at 11:20 a.m. Use 10 minutes to solve this question. Keep your put your answers in the chat. Okay, so we're gonna come back. I'm gonna show you the simulation of this projectile happening actually, and then we'll talk about a few things. We'll check whether your answers are correct or not. Okay, so see you at 11:20 a.m. Let's have breakfast. Yes.
Sir, I have a doubt on how t is equal to u sin theta by g. And
Which-
where did 2 go?
Which slide?
The previous one, just before the question.
This one?
So can you scroll down?
This one?
Down, down.
This one?
No, down.
This one?
Just before this question, the recent one.
Oh, okay, this one?
Yeah.
Excuse me,
There,
sir.
t is equal to u sin theta by g, right? How is it? Where did the 2 go?
I didn't understand your question. Can you repeat? I'm actually not audible properly.
So the time of flight is equal to 2 u sin theta by g, right? So
Yes.
where is q over there? What happened to the
Oh, what happened to the 2 here?
Yeah.
Okay, cool. See, 2u sin theta is the time that it takes for it to go and then come back to this position. Yes or no?
Yes,
Okay.
sir.
But h max is reached when the body is reaches here. Does that make sense?
Yes, sir.
Okay, so that's why we are taking half the time. This is essentially half time. T
Yes, sir.
half. Did you get it?
Yes, sir. Got it.
Okay. Okay. So yes,
Excuse
I'll
me,
see you.
sir.
Yes.
So I had a doubt in non-uniformly accelerated motion in one of the assignment questions. Could I send you it on WhatsApp?
Yes, please do.
Okay, sir.
Any other doubts? You can send it to me through WhatsApp directly. I'll try to solve them. Okay. So see you guys in a bit. 11:20 a.m. is the time when we meet again. Okay. Do this particular question. 30 degrees launched. Okay. 30 degrees is the launch projectile angle. Initial launch velocity is 30 meters per second. Was it 30 meters per second? Yes, it is
Yes,
30
sir.
meters. So U is 30 meters per second. Okay. and you have to find out all the details here. What is the time of flight? What is the range? What is the H max? Yada yada yada. Okay. So find it out, guys. I'm gonna see you back after some time. Okay. Put your answers in the chat and then have breakfast. I'll also have my breakfast. Meet you very, very soon. Welcome back, guys. Yes, very nice. Yeah. So as I was speaking, what are we talking about? Yeah. Did anyone manage to get their answers? Am I
Yes, I
audible? Are
sent
you
you.
guys back?
Yes, I have sent you the answer.
Namish, Karthik, and Rishi have answered. What
Sir,
about rest?
excuse me, I
Rest of you
actually had
guys?
a doubt.
Rest of you guys, can you type your answer in the chat? Three. Oh, time of flight is three. Okay. 15 root 3 as the range. 15 root 3. 11.2. Okay. Lydia has answered. Who else? What about uh, Purva? Purva, Ishani? Don't see no answers. Okay, cool. Let me do this question and you guys tell me whether you understood how to do it or not. Okay. Yes. Okay, cool. So, yep. Anyways, so how do I start doing this question? Well, I first take components. Yes, guys, this is the first step. Okay. Please let me know if you have any doubt. Ishani has answered yes. Cool, cool, cool. So if you think about it, first job is to break this velocity into two parts. The horizontal component will be how much, guys? How much will be the horizontal component? Is going to be u cos 30. So that would be 30 cos 30. So that's 15 root 3. That's like 15 root 3 meter per second. Now, I have a calculator. Let me just find it out. In exam, you don't essentially need to break it, but just for the sake of it, I want to find out. So root 3 is 1.732. Multiply that with 15, and your velocity is 20, close to 26. It's like 25.98. So it's like close to 25.98 meters per second. So in the horizontal direction, the body's velocity is essentially 26, approximately 26 meters per second. What about the body's velocity along the vertical direction, guys? Along the vertical direction, can you tell me what is the body's velocity in the vertical direction?
It's 15 meter per second.
It's going to be 15 meter per second because it's going to be 30 sine 30. Sine 30 is half, so it's going to have 15 meter per second as the vertical velocity. Okay. So I know a few things about the y-axis now. In y-axis, I know that the final displacement is going to be zero because we are talking about the ball going up to a maximum height and then coming back to the same location. Okay, coming back to the same location. So that would mean the displacement is zero in the y-axis. In the x-axis, it's range. The initial velocity is 15 meter per second and the acceleration is minus 10 meter per second square. Well, if nothing is said, then gravity you can take as 10 meter per second square. Okay, so minus 10 meter per second square. So again, I'm not using any formula, but if I use I'm using the process here. I'm going to use the equation of motion here. S equals to ut plus half at square. I'm going to use. So displacement is going to be 0. 15t plus half into minus 10 into t square. This is me just plugging in the values. Okay, so that's 0 equals to 15t minus 5t square. So 5t square goes to the other side, and then t comes out to be 3 seconds, guys. So your answer about 3 seconds is absolutely right. This is absolutely right. We got the time of flight as how much? We got the time of flight as 3 seconds. Any issues with this, guys? Any issues? No issues. I'm going to transfer these calculations to the other page. Okay. Control X. Let me put it here. These are the calculations. Okay. So I found it. Next, how do I find out range? Guys, how do I find out range?
So using third equation of motion.
Yeah. Well, you don't have to use equation like third equation or second equation.
Or
only
we
is
can
relevant.
use the direct formula.
Direct formula, which is like if you want to find out because there is in x, think about this, in x-axis the initial velocity is 25.98 meter per second and the time it traveled is 3 seconds. We just found it out, it's 3 seconds. We want to find out what is the distance it traveled. Okay, so since there is no acceleration, I can simply say distance is equals to velocity into time s equals to ut, because there is no acceleration, a equals to 0. So that would mean 25.98 into 3 seconds. That's it. That's all you had to do. Okay. And this will come out to be how much? Let me put the calculators in. I think 45 root 3, right? Because 15 root 3 into 3 is 45 root 3. What I'm going to do is multiply this with 3 and I'll get close to 77.94. That's close to 78 meters. Okay. So if I move it slightly up, this range, okay, this is actually capital R. Capital R is going to be equals to 77.9 meters, which is approximately 78 meters. Okay, so this is what range is found out to be, 77.9 meters. Please let me know if there is any issues here. This is how I found out the H max. Oh, sorry, range. Okay, putting it in the next slide. Okay, so I found out the range to be 77.9 meters. Now, how do you find out, in which axis do you find out H max? Well, in the y-axis. In the y-axis, again, I know a few things now. I know the initial velocity is still 15 meter per second is the initial velocity. Displacement is what we have to find out. It's going to be H max. Well, final velocity at the highest point is going to be 0. And the acceleration is minus 10 meter per second square. So which equation do you think I should use? Well, v square minus u square is equals to 2as. Well, v square is 0. So 0 square minus 15 square is equals to 2 times of minus 10 into h max. Okay, so that's 15 square is 225 divided by 20. So your h max will approximately come out to be, let me use the calculator. 220. 225 divided by,
So I got it as 11.25.
yes, 11.25. It comes out to be 11.25. Okay, so this is your final answer. So you got 11.25 meters as your maximum height. Okay, this is how you solve. This is how you solve your projectile based questions. It is pretty much the idea where you find out x-axis components, y components separately. Once you do that, you start applying the equations of motion. And after you're done with equations of motion, time is the quantity that's constant in classical mechanics. It's not gonna vary depending on the x or y axis. So it's gonna be same whether you find it in the x or y axis. You can actually use that particular information to find out the range and all. Okay. So this is how you do this problem. I want you to notice a few things. For that, I want you to I want to show this particular stuff in simulation once. Okay, just for you to notice a few things. Where did it go? Yep, sure. Okay, guys, I hope you can see my new screen here. Okay, so the initial velocity we took was 30. Okay, so this is a simulation where I can change the velocities and everything. So here I will put 30 here is the initial velocity. Gravity we took as 10, right? So I'm going to plug in gravity, acceleration due to gravity 10. The launch angle, I believe we took 30, right? Yeah. And yeah, but there was no why not. We released it from the origin itself. Okay. So guys, first of all, let me tell you, let me show the, not, let me not show the components right now. Not show the velocity vector also. Let's just fire the projectile and see what happens. So this is how the projectile goes. Okay. Let me reduce the animation speed slightly. So this is how the projectile moves. Okay. And all the parameters are actually going to be shown here. Okay. So let's cross check. First of all, I need you to understand how the velocity vector looks like. Okay. The velocity vector of the ball initially is pointed at 30 degrees, but as soon as it's launched, that angle is going to change. It becomes horizontal there, and then it starts coming back down again. Okay. If you think about the components, and this is where we start, looking at the numbers here. So at the bottom, you can see Vx. What is Vx, guys? This is essentially the x component of this velocity. Do you remember it was 25.98? We found it out, right?
Yes, sir.
Do you remember it was 25.98? 15 root 3 was 25.98 meter per second. That is the x component of the velocity. Vy is essentially the y component of the velocity. That's 15 meter per second. We have found this, guys. I need you to recognize these numbers, okay? And v equals to 30 would mean the net velocity. At any instant in time, this is going to give us the net velocity, okay? First, I want you to notice Vx for this entire motion. I want you to notice only Vx, okay? So I'll fire the ball. I need you to notice Vx. And someone needs to tell me the conclusion of why that is happening. Okay, so let's fire this. What is happening to Vx, guys? What is happening to Vx? Vx, what is happening to the x component of the ball or the projectile during this entire
That's
motion?
constant.
It's constant. Now tell me why. Why
So
is
there's
it
no
constant?
acceleration acted
Yes.
upon in that direction.
Yes, there is no force in the horizontal direction, which implies there is no acceleration in the horizontal direction. Hence, the x component of this ball is same throughout the motion. It's same throughout the motion. Okay, now let's look at Vy. Guys, let's only look at Vy this time. Okay, so notice how it starts at 15 meter per second, and I'm going to fire. What is going to happen is going to keep on decreasing. It's going to keep on decreasing till it becomes zero. It becomes zero, and then it starts coming back down. It starts coming back down, and it starts increasing in velocity in the opposite direction. Tell me why. Why is this happening? This is because
Because
in the
velocity becomes zero at its max height, and then once it goes down, velocity becomes negative because it's in the downward direction. And here
yeah, velocity,
gravity.
because gravity is acting downwards, and the ball was thrown upwards. So initially it decreased in velocity till it became zero at h max, and after that it started coming back down. So its velocity again started increasing in the opposite direction. That makes perfect sense. Now the next part. Do you remember we found out the time? So this is the time is at the bottom. Here also it is there. So I'll try to stop I'll pause the projectile exactly when it touches the ground. And let's see, I think we found out as 3 seconds, right? So let's see if we can simulate that. Let's see when it touches the ground. Okay. So let me pause it as soon as it touches the ground. 1, 2, 3, go. Oh no, it's too fast. Okay, so yeah, this is the point where the projectile hits the ground, guys. This is the time when the projectile hits the ground. Notice the time is 3 seconds here. Okay, and y is 0. Y means the vertical elevation. The elevation has now again come to 0. So elevation is essentially from the x-axis is considered to be the ground. How high is it from the ground? So y is 0. What is this x? X is the displacement. X is the displacement along the x-axis. 77.94. Does it look familiar, guys? What is 77.94?
It's the range.
It is the range. Okay. If you remember, we found out the range to be 77.94. Let me just cross-check once.
So could you repeat what y was?
Y was the elevation from the ground. Okay. So range we have got as 77.9 here. And if I go back to that simulation, you will notice that when the ball has reached that final position, X value has become 77.94. Okay, it has become 77.94. So Okay, my bad. Yes, let's continue. The next thing I want to know, the last thing that I want to find out is the maximum height. How do I know the maximum height? When time is 3 seconds. At what time will it be at its maximum height? Can someone guess? At what time will this projectile be at its maximum height? I know the total time of
At
flight is
1.5 seconds.
at 1.5 seconds. So I'm going to tally this to 1.5. Uh, Let me decrease it slowly here. 3, 2, 1, 0. 1.5 seconds. See, what are the few things that you notice in 1.5 seconds? The first thing is that X value is 38.97, which is exactly half of the range also. So the H max is reached at half the time and at half range. Both of these statements are true. Second thing, here in y, you see the y value, the elevation is 11.25. Do you remember what 11.25 was? It was the h max. So 11.25 here is representing the h max, that is the y value right now, that is the elevation from the ground. Okay, one thing you need to notice is vy is equals to 0. Vx is still 25.98. What is the net velocity, guys? What is the net velocity at the highest point? Is it 0?
No, sir.
It is equals to the x component. Okay, so the final thing I want you to notice is this value of net velocity. Remember, we send in this body with 30 meter per second. Okay, let's see what happens to the values of this. Okay, so I want you to only look at the final velocity here. Forget the components for now. So let's fire. So the velocity decreases, 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 and it becomes equals to how much? 25.98, and then it starts again increasing. It again starts increasing. When it reaches the final position, so let me, micromanage this. Tell me, what is the velocity that the body has when it reaches back to Earth? Look at the value. Tell me why am I getting 30 meter per second? Guys, this can be explained from the basic conservation of energy. You threw something up with 30 meter per second, it's gonna come back at 30 meter per second. Why? Because all that energy was converted into potential and potential back to kinetic. Okay, so if you throw something at an angle of 30 meter per second, it's gonna come back at 30 meter per second. The components will be adjusting in such a way that the body reaches at the same velocity. So one thing I wanted to tell you about net velocity is that unlike y component, which goes up, becomes 0 at the highest point and starts coming back down, the net velocity of the body goes from the maximum value at the beginning to till it becomes equal to the x component at the highest point, and then again it starts increasing in the downward direction. Does that make sense, guys? Please let me know if there is any doubt in what I'm speaking. Let me repeat one more time. If you have v given to you as 30 meter per second and its horizontal component was 25.98, that value of 25.98, the horizontal component, is never going to change. So the net velocity is going to decrease slowly up to the horizontal component, which is 25.98, and then again it starts increasing. Okay, this is because y component is the only one that is varying, x component is unchanged. So when y component becomes 0, then v net becomes equals to vx. Let me repeat one more time. At the highest point, the net velocity is actually equal to the horizontal velocity. Okay, the horizontal component of the velocity. I hope that made sense. This is all I had to discuss about projectile motion. Now it is time for us to do as many questions as we can. So last 1 hour, I think we have 1 more hour left. So we'll be doing as many questions as we can from projectile motion. Okay, we'll also take up different applications of this, like what happens if we throw it from certain height, what if we throw it to the to a inclined plane of sorts. Okay, so all of that we are going to discuss under the application part of it, but the basic projectile is done. Okay, so let's graduate into questions. Please ask me doubts if you have any. Look through your notes. Remember the formula. I'm going to ask questions based on this. Let's start with some easy problems. Okay, guys, on my first question. Guys, try this question. Put your answers in the chat. Guys, are you done? Give me the answers. Awesome. Uh, this is a very repetitive question. We have learned all the formulas. I'm getting a lot of answers here. So let me plug it in. Time period is what? 2u sine theta by g. So that would mean 2 times of initial velocity is given to us as 20 meters per second. Angle is given to us as 45 degrees. Acceleration is given to us as 10 meter per second square. This is the magnitude. Since I'm directly using the formula, I don't need to use the convention. So 2 into 20 meter per second, sine 45 is 1 by root 2, g is 10. So it's going to be 2 root 2. Time is going to be 2 root 2 seconds. So that root 2 is 1.41. So 1.4, it's essentially 2.8. Okay, so approximately 2.8 seconds it's going to take to complete that flight. The maximum height it reaches, h max, is given by the formula u square by 2g. Sorry, u square sine square theta by 2g. Okay, that would be how much? U square is 20 square, that's 400. Sine theta is 1 by root 2, but square of that will be half. And then 2 times of g is 10. So one of the 10s cancels with 0. I think it's going to be equal to 10 meters. Okay, because 2 2s are 4, 4 cancels out, so only 10 remains. So r, the range is given by u square by u square sine 2 theta by g. Okay, u square sine 2 theta by g. So u is again 400 by 10, and sine 2 theta this time is just 1, because 45 degrees is 2 times of 45 degree is 90 degrees, sine 90 is 1. So your range is going to be 40 meters. So I hope everybody got these answers correctly. If you have any doubt, please ask. I think most of you got it correctly. Okay. Now for the next question, let's increase the difficulty slightly. Okay. This is the question. Here you can't directly use any formulas. You have to go from the basics. You have to pretty much understand what is going on here if you want to solve it. Anybody got the answer, guys? Okay. I
So
have
I
a GIF.
almost got it, sir, but it has a root, so it's a bit tough to type it out.
Okay, so it's okay. It's okay. If it has a root, then it's correct. Guys, people who didn't understand what is going on, this GIF is going to help you visualize what exactly is going to happen. Okay. So guys, look at this. The helicopter is going to release a rescue package, and from the side, this is how it looks. Okay. So it's going to be essentially like half a projectile. So you have to do that complete analysis. Okay. So the helicopter is on a food relief mission flying horizontally with a speed of view at an altitude edge, has to drop a food packet for a victim standing on the ground. Now, the first thing people need to understand here is that when the plane or the helicopter is going to release the packet, what is going to be the velocity of the packet? Is it going to be 0 or is it going to be
So in the downward direction, it would be 0, but in the horizontal, it will be u.
okay? That perfectly describes it. What about others? What do you feel? Is it going to be 0 when the velocity when the helicopter releases the package? Is the initial velocity going to be 0 or is going to be u? Okay, well, the answer was okay, cool. So the first thing you have to understand is, imagine if you're traveling inside a bus. If the bus is moving at 10 meter per second, you are also moving in, at 10 meter per second with respect to the ground. Okay, please understand. Don't feel like this, sir. I am sitting down, so how is my velocity 10 meter per second? If you are inside the bus, then your velocity is 10 meter per second. So if I just if I drop you from the bus, you're not just gonna, fall straight down like that. No, it's not gonna happen. If I throw you out of the bus, you're gonna travel like this, and then you're gonna, fall down like this. I hope that made sense. Okay. So that's the same concept I'm using here. If the rescue package was inside this helicopter, as soon as you release it from the helicopter, it's going to have the same velocity as the helicopter. So you're talking about a package which has initially a horizontal velocity and it's going to follow down on a projectile path like this. Okay. So if I play it back, this is how it looks. Okay. This is how the package is going to come down. Now, what do we do? How do you solve this? Well, same concepts. Okay, so it is given to us that this value is h. Okay, initial velocity is u in the x-axis, but what about the velocity in y-axis? Well, it does not have any velocity in the y-axis. So if I break it into two parts, well, y-axis may also, let's stop this. This keeps distracting me, so I'll stop it somewhere here. Yeah. In y-axis, we have a few things. The first one is initial. How much is the initial velocity? Well, it's going to be 0. Okay. How much is the displacement in the y-axis, guys?
So it'll be h.
It's going to be minus h.
Okay,
Remember,
sir.
we're dealing with vector quantities here. Okay. Otherwise, your time will come out to be negative. Don't do this. Okay. Displacement is minus h because the body from its location traveled downwards. And by our convention, most of the time we take downward direction displacements or velocity or acceleration as negative. So s is negative. What about the acceleration, guys? It's going to be minus g. So can we find out time from all of this? Yes, I'm going to use which equation? S equals to ut plus half a t square. Does this make sense, guys? Guys, does this make sense? Okay. So s is going to be minus h. U is 0, so this term is 0. Half of minus g t square. Minus g t square. Okay. So how much is time, guys? How much did time come from here? So if you take 2 to the other, minus minus cancels, 2 goes to the other side. So you have 2h by g, but don't forget the under
So
root.
we have to put the root over it.
Don't forget the under root, put the root here. Okay. So the time we have found is under root 2h by g. But that is not the question. Okay. I understood that this block is going to take a time of under root 2h by g to come back down to earth. But that's not what they are asking. They are asking, okay, sir, what is this distance that it is going to cover? If you read, at what distance from the victim should the packet be dropped? So that means they're asking us, how much is this range? Well, I have time now. I know the horizontal velocity. How much is the horizontal velocity, guys? In the x-axis,
So it's u.
its initial velocity is u. Yeah, initial velocity is u. And time is how much, guys? Under root of 2h by g. We just found out. So how much will be the range? Well, just u into t. Well, u into under root of 2h by g. That's it. This is how this is known as, this topic is known as horizontal projectile.
So I have a doubt.
Yes.
So I got the answer till here, but I thought the distance would be the distance of the helicopter to the distance of the victim. So I thought it would be the hypotenuse. Do we need to find that, or the vertical horizontal range?
See, the question was asking at what distance from the victim should the packet be dropped. Okay.
Okay.
I understand why you got, why you had the doubt.
Sir,
Yeah.
I didn't understand why u is equal to 0.
That's because in the downward direction, we just released it from the helicopter, right? So because of the velocity of the helicopter, the rescue package had the initial velocity in the horizontal direction, but in the vertical direction, there was no push given to it. So initially, it's like releasing something from some height. Imagine. Okay, if the helicopter was hovering instead of moving, and you released it from a certain height, it would, both of them would be 0, right? Like the x component as well as the y component is going to be 0 because you released it, you dropped it from a certain height. When you say dropping something, it essentially usually means it doesn't have any initial velocity. Does that make sense? Does
Yes,
that
sir.
clarify your doubt?
Yes, sir.
What else? Yeah, regarding your doubt, see, this question is from H.C. Verma. They should have mentioned the at what horizontal distance. Okay, so yeah, that is something they should have mentioned here. But yeah, your analysis is actually correct. If they just ask distance, probably we'll have to take this hypotenuse distance. Okay, but the solution also they have done. They have done it like this. They have considered the horizontal distance. Okay. horizontal distance. Okay. Yes. Any other doubts? Please let me know. Let me know if you have any other doubts. No doubts in this question? Okay. Let's do some more. The more questions you do from this topic, the better you will get at it. Okay. So do as many as you can. This next one is going to be very difficult. Okay, wait. Before I give a very difficult question, mm, should I give you a slightly easier one? I don't want to. I don't want to increase the difficulty too fast. Okay. Hmm, I like this question. Okay. It's slightly again, as the class progresses, I'm gonna give you more and more uh, difficult questions to solve. So again, don't be alarmed by this, because if you're unable to do the question, it just means that you need to do more. Uh, you need to do more practice on base level questions. Now, once you're done with that, then but I'll have a very short window to do questions. So progressively, I'm going to make the questions more and more difficult. So if you're unable to do it, just means you need more practice of easier questions. So do that back at home. I'm going to give you assignments, and no need to worry. Yeah, just attempt this question. Let me know if you can do it. Yes, guys, is anyone able to solve this? Please let me know. I'll start
Yes, sir.
solving
Two
this.
minutes, I'll be done with it.
Okay. Okay, let me explain how to do this question. Okay, please type in your answer in the chat if you got. No need to worry. Okay, so this is one of those situations jahan pe you're throwing something from a certain height. Okay, so please understand this is like just like this was slightly different from the original projectile motion. Here also you cannot directly use the formulas that were given. Why? Because again you have to understand those basic formulas were given when the projectile was launched from the same horizontal uh, elevation to the same horizontal elevation. Okay, so those formulas like 2u sine theta by g is only valid in the basic case when the projectile starts from ground, ends at the same level. Okay, but this time things are different. The person is standing on a cliff, like he's at some height, uh, and that height is essentially you know this height is essentially how much? It's 171 feet. Okay, throws a packet to his friend standing at the ground, uh, and this person is standing right here. His friend is standing right here. The person who is throwing the projectile is standing right here. Okay, so this distance, this vertical height is 171 feet. Okay, and this horizontal distance is actually 228 feet. Okay, so when he threw the packet, well, he should have thrown it like this, right? He should have thrown it like this, then it would have gone up and then it would have reached him. But he a dumb person. Okay, he's a dumb person. He did not do that. What he did is he threw the packet directly aiming at the friend. So he threw it like this. Okay, now it's not a laser that the packet is just gonna go and hit the boy. It's not a laser, dude. Okay, so the block is going to essentially just go, but it starts dipping down. It starts dipping down and it's gonna fall like right here. So the question is asking how short did the packet fall? Like they are asking us essentially what is this distance right here. Okay, so let me change the color. I'm bored of pink. This distance is how much they are asking. Okay, but for this you have to essentially find out what is the initial angle of launch. What is the initial angle of launch? Okay, I'm going to be very cheeky while finding out this angle. See how? Okay, let's see how. If you join this line to this person, this makes a right triangle. If you think about it, it makes a right triangle. Okay, in this right triangle, this angle is going to be same as this angle. Like this is the launch angle, right, with the horizontal. Don't be afraid, he said this time u is downwards, it's below the x-axis. No need to worry, the principles remain the same. Okay, the theta is just downwards. I just need to find out the value of this theta. Well, I just came to realize that tan theta is perpendicular by base. Well, that is how much? It's 171 divided by 228. Just let me divide 228 divided by 171 is 1.33. Well, how much is that? 171
So
divided
this
by.
one simplified is actually tan theta is 3/4.
This is essentially 3 by 4. Very nice. 0.75. Okay. So this is actually 3 by 4, guys. You can do this. I believe in you. Okay. I believe in you. You can find that this is 3 by 4. Okay. I'm not explaining how to do that. I think 3 se cancel hoga, right? 3, 7, 1, 3. Yeah. Both of them will get cancelled with 3, and after you divide with 3, I think again with 3 it will go. Do you want me to do it? No, I'll not do it. Never mind. So if I know tan theta is equals to 3 by 4, I know definitely sine theta is going to be 3 by 5, and cos theta is going to be 4 by 5. Very nice, guys. How did I know this? Well, tan theta 3 by 4 means it's a right triangle with this as 3, as this as 4. That means this is going to be 5, right? So sine theta is 3 by 5, cos theta is 4 by 5. So that's how I got it. Like if one of the trigonometric values is given, the rest you can find out like that. So you know sine theta and cos theta. Okay. You also know the initial launch velocity. Well, the initial launch velocity is given to us as 15. Okay, I'm ignoring the units because all of them are in feet. I'm very uncomfortable with feet. Okay, so I'm just gonna write 15 here. So initial velocity is 15, and well, initial velocity is 15, but I don't like this again because it's in a random angle. So I'm going to take what components. So can you tell me what will be the horizontal component? Well, it's going to be u cos theta. Towards theta is cos theta. How much is the vertical component? Well, vertical component is going to be how much? U sin theta. We have all the values. Students, we have all the values. It may look like a fancy question, but we have all the values here. How much is u cos theta? Well, u is given to us as 15. Cos theta we found out to be 4 by 5. So how much is u cos theta, guys? 12 meter per second. Oh, sorry, 12 feet per second.
12.
So in the x-axis, we already found out the initial velocity to be 12 feet per second. Very nice. What about y-axis? In y-axis, what is the
9.
initial? It's going to be downwards, and it is u sin theta. U is 15. Sin theta we found out as 3 by 5. So I'm going to plug this in. So I got 9 feet per second. But please don't forget to put a minus sign here. Why? Because
Minus
it is
sign.
coming. It's coming down. Okay. Now, in y-axis, guys, think about this. How much is the displacement? How much is the displacement in the y-axis? In earlier projectiles, it was what? 0 minus h. In this projectile, what is the displacement? Where did the ball start from and where did it end in the
So
vertical direction?
171.
It is going to be minus 171 feet. Minus 171 feet. Why? Because from its original position, vertically, it came down by 171 feet. 171 feet. Okay. What about acceleration, guys? What about acceleration? Well, don't say minus 10 because it would be wrong. We have to do it in feet per second square. Okay, what do we need? Well, we need the horizontal. Yeah, we'll need the time. So we'll have to convert this into feet per second square. Why didn't they not give us that value? I think they should have given us.
Sir,
that
we'll
value.
just change it to meters.
Yeah, we can. Give me 1 second. Gravity in.
It will be 32 feet per second.
So I
Second
just
square.
go 32.17. Okay, so we'll just take 32. We'll take 32. Okay, sorry, this value I should have given before only. So it is minus 32 feet per second square. Okay, feet per second square. Okay, this is feet per second. No, it's just feet. Okay, so sorry for the weird units. Usually you'll get all the questions in standard units only. Okay, so this is just an exception. Don't worry about this too much. Just concentrate on the process. So how do I find out time? Again, s equals to ut plus half at square equation I'm going to use. Okay, s is minus 171. U is going to be minus 9. Okay, t is what we have to find out. And then plus half into minus 32 into t square. So this is going to give us a quadratic equation that is 1 minus 171 minus 9t minus 16t square. Okay, so if I write it here, this is the quadratic equation I got. 16t square plus 9t minus 171 is equals to 0. Has someone solved this and found out the value of time? No? Well, let me plug it in. Okay. Sorry about the questions. Numerics. It's like taken from HC Verma. I don't know when did they start giving out this fancy calculations. Okay. So no worries. No worries. Let me just plug this in and let's find the answer to this. So we have a quadratic equation. Coefficient A is how much? 16. Question B is 9. And C is minus 171. So the values is minus 3.5 and 3. Okay. So the time comes out. There are every quadratic equation has two solutions, right? So we have 3 and the other one is minus 3.5. Which do you think I should take?
3.
3. Okay. So t comes out to be 3 seconds. So 3 is a root of this equation. Okay, so t comes out to be 3 seconds. Now, after I have found out the time to be 3 seconds, guys, can you tell me How do I find out this distance from here to here? Well, I know the velocity in the horizontal direction is how much? Horizontal velocity is 12 feet per second. And this is going to travel for 3 seconds. So guys, tell me what is this distance right here? It's going to be simply 12 into 3. So that's 36 feet. It's going to travel 36 feet. Okay. So what is the distance? Like how much distance does it miss? So it's 228 minus 36. Okay, so something like 190 something it will get. So the distance he misses out. Oh my God, why is it like that? Okay.
Sir, could you explain that 12 into 3 once?
Yes, in the x-axis, the acceleration. I'm doing the analysis on x-axis now. See, in the x-axis, I have already found out the velocity to be 12 feet per second. I know the acceleration is 0. So the displacement will be simply u into t. Yes or no? So 12 feet per second into how many seconds? Well, 3 seconds, because we
3
just
seconds.
found out. So this distance comes out to be how much? 36 feet. So in the horizontal distance, the projectile has traveled 36 feet. So how much distance does it come short? Well, 228 minus 36, which is, give me 1 second, 226 minus 30, 188. Okay. No, 182. Okay.
So it'll be 192, no?
The 192.
192, sorry. So the correct answer is 192 feet. It comes
So
short by
now, if
distance.
we get this kind of question in our school exam, how do we split that 16t square plus 19 and more easier way?
Can you repeat one more time?
So like if not only in this question, if we get any quadratic equation as the final answer and we're supposed to find it, and it's like complicated, like 16t square plus 90 minus 171, how do
Huh.
we split it in an easier way?
Well, split middle term split is not going to work here. So you have to work with b square minus 4ac on this one. So 9 square is 81 minus 4 times of that's essentially plus 4 times of 16 into 171. Okay, so you have to hope to find out a perfect square on this one. So let's see how much is this. 16 4 is 64 into 171. 171 into 64. So 4 ones are 4, 4 7s are 28, 2 4 ones are 4, 5, 6. 6 ones are 6, 6 7s are, what is 6 7s are 42, right? Sorry, 6
42,
ones are
4, 10.
10. So that's 4, 2, 1, 9, 0, 1. Okay, plus 81. Add 81 to this. So this becomes 5. This is 1. So
Sir, won't it be 10944?
will it be 4 4? Oh yeah. 8 plus 6 14. 1 8 9. Yeah. Sorry, this is 5. 8 plus 4 is 12. Goes 1 goes up. So this is 1 1 1. So 11025. I think this is a perfect square. Right? Ooh. Let's check out. 11025 under root.
Yeah, it's
105. Yes.
105.
Yes, 105 square this is. Okay, so that means you just have to hope that this is going to come out to be a perfect square, and the way to check
Perfect
is,
square.
see, this is close to 100 square because it has 4 digits after 1. So after that 100 and it is ending with 25, so that is definitely you have to check 105. Okay, because it can end with 5 when you have 105. That's your only route to check. Okay.
Okay,
uh,
sir.
so once you have that, then you can use minus b. Minus b is how much?
Yes, sir.
Minus 9 plus minus 105 by 2 times of 16.
By
Okay.
32.
So in this one, you have to ignore the negative one. Just go for 105 minus 9 divided by 32. And I think you'll get 3 seconds from here. Yeah. Yeah, you'll get
Yes, sir.
90, 96. 96 divided by
96 by
32 is 3 seconds, right?
Yes, sir.
So this is how you can do it in school exams, but please be advised it is not going to be that difficult in your school exams. Okay, even in JEE mains and stuff like that, they are not going to ask you calculation intensive questions. This is very calculation intensive. Okay, and they will clearly mention the acceleration, which they did not in this book question. But if such question comes in your competitive exams, they will mention this acceleration there. Okay,
Okay,
sometimes
sir.
they may just see, they may just give this kind of question so that you waste time on that question. Okay, so if you get very calculation intensive question, those are not high priorities. First is like you have to do all the conceptual questions first. Now then after that, if you have time left, then you should go for calculation intensive question. That's the strategy for a JEE main based questions. Okay, so but I hope you understood how I did the question, because the process was very important. If you didn't understand any part of this, please let me know. Okay, last and the final question that I wanted to check with you guys, and again, this is going to be very difficult. Okay, I'm just gonna say upfront, this is going to be difficult because you are not used to doing this level of question. Okay, so I'm gonna teach you how to do it. Definitely, I'm going to show you how to do it. Uh, Also, I need you to just guide me through if you have any doubts. Okay, so if you have any doubts, that's where you need to tell it so that I can help you, clarify your doubts. So it's going to be very crucial that you ask me the doubts. Otherwise, I'll not know where you didn't understand. This is the question, and this is the last type of question that I would like you to check out before you go. This is a projectile which is thrown from an inclined plane. Okay, so I have a situation like this. It's not very similar to what the question is asking, but it is essentially the idea of what is going on. Okay, so give me 1 second. Let me pull up that diagram. Okay, so this is what I'm talking about. Okay, so guys, this is an inclined plane. Okay, this is not the same question. See this right now. Let me just cut it off. Okay, this, imagine what I'm trying to do here. I am throwing a projectile over an inclined plane. Till now, our projectiles were always on the ground like this. Okay, the projectiles were always like this, but this time the ground on which you're doing the projectile itself is an incline, so it goes something like this. Okay, so but again, it's not gonna go perfectly symmetrical as in the even ground. It's gonna go something like this. So this is not gonna end up perfectly symmetrical. Okay, and a calculation for h max etc will also be kind of different. It's going to be kind of different. Okay, so I hope you understood what is going on. This time again we have to consider two things happening here. One is the movement along the x-axis. You can see they are trying to portray this projectile motion as the motion of two different balls. One is along this tilted x-axis. Now the tilted x-axis earlier was like this, and y-axis was like perpendicularly upwards. This time the x-axis is going to be like at an incline x. Okay, and y-axis is going to be perpendicular to this. So here you can see the y-axis and the x-axis tilted like that. This is the motion of the ball here, and then it comes back. In y-axis also it goes up and comes back. See, in the previous projectile, the x-axis did not have any acceleration, but this time it's going to have. Can you tell me why? I'm going to show you why. See, gravity is perfectly downwards like this. Okay, I need you to look at what I'm going to explain here, because that's why I turned it off, because I need you to focus here. Okay, so let me make the inclined plane first. Let's say this is the inclined plane. We call this what? And I write it down. This is known as inclined plane. Okay, this angle right here is known as the angle of inclined plane. This is known as the angle of inclined plane. Okay, now what happens is that whenever we talk about gravity in the normal frame of reference, like this is x, this is y, and this is gravity right here. So you will say gravity is perpendicularly downwards and it's always in the y-axis. But here the gravity is downwards, but my axis is now tilted. It's along this. This is like x-axis, this is y-axis. Okay, so gravity is actually making an angle with the current x-axis. So if you think about it, this is the direction of g. Like perpendicular to the ground, but not perpendicular to the x-axis at this time. I hope this is making sense. Guys, is this making sense? Do you understand the fact that gravity is now no longer along the y-axis?
Yes, sir.
Okay. Now you need to figure out what the angle is, right? You have to figure out what the angle is. Well, I know how much. Well, if I make if I extend this red line downwards, can you tell me how much this angle is?
That's 90 minus theta.
This is going to be 90 minus theta. Very nice. So this and this are vertically opposite angles, yes? So this angle is how much?
90 minus theta.
90 minus theta. So how much is this angle?
That will be theta.
Theta. Okay. So that's the geometry I wanted you to understand. If you understood the geometry, I'm going to erase it. Guys, let me know if you understood the geometry. What did I do? Well, I'm going to do it one more time just for the sake of it, because I don't want anyone to miss this. I knew that the gravity is perfectly downwards. What I did is I extended this downwards. Okay. And this is going to be 90 degrees. So this angle is going to be 90 minus theta. Now, if you look at this, this and this is vertically opposite angle. So this is going to be 90 minus theta. So this angle is going to be theta. Okay. So I showed it for the second time. If you didn't understand, let me know. I'll explain again. Okay. So this angle right here is theta. Now it is possible for me to take components now. Okay. So towards theta, guys, towards theta, it will have two components, one along the y-axis and one along the x-axis. Tell me the component along the y-axis. It's going to be g cos theta, right? And the component along the x-axis is going to be g sine theta. Why? Because theta is with the y-axis. Please let me know if that made sense. All in all, the conclusion is this. Okay, the conclusion is this. I'm going to draw it here. If you are at an inclined plane, whose angle is theta, then the gravity on this plane will have two components. One along the plane, that is going to be g sine theta, and one perpendicular to the plane, that is going to be equal to g cos theta. Please let me know if that made sense. Guys, did it
Yes,
make
sir.
sense? Okay, so that means the ball. Okay, so let me bring back this simulation right here. In this simulation, you can see that the ball is going up, slowing down, and then again coming back. This is happening because this time in the x-axis also there was what? There was acceleration. That's the reason it's returning back. See, in the horizontal direction, there was never this phenomena of returning back, because it is always going in the forward direction with no velocity change. But the fact that this velocity along the x-axis becomes maximum and comes back proves the fact that there is acceleration along the new x-axis. Okay, and there is obviously going to be acceleration along the y-axis. So if I had to essentially, take components here, then in the y-axis, earlier the acceleration used to be minus g. This time is going to be minus g cos theta. And earlier in the x-axis, the acceleration was 0. This time the acceleration is going to be minus g sine theta. Does that make sense, guys? Guys, please let me know if this made sense.
So I didn't understand why minus d cos theta.
Which part you didn't understand?
The acceleration minus d cos theta.
Acceleration being x. Yes. So let me repeat one more time. See, earlier what was happening? Again, I'm going to show it with a diagram. Okay, earlier the acceleration was like this. This was horizontal x-axis, this was vertical x-axis, and the gravity was simply downwards. So you used to say, okay, to represent this, the acceleration along the x is 0, the acceleration along y is minus g. Please tell me whether this one you're able to understand. Earlier, this was the scenario.
Yes, sir.
Okay, but this time the reference axis is now tilted. The x-axis is now at an angle like this. This is the new x-axis, this is the new y-axis. Okay, so here the g is now no longer along, this is no longer valid here. Okay, so I can see along the x-axis there is an acceleration of g sine theta in the opposite direction. So I wrote along the x-axis the acceleration is g sine theta, and in the vertical direction we can see that the acceleration is g cos theta. So I wrote minus g cos theta. Does this clarify? Please let me know if you
Yes, sir.
didn't understand. Which part you didn't understand?
So now I got it.
You got it?
Yes, sir.
Okay, cool. So in the y-axis, the acceleration is minus g cos theta, ax is minus g sin theta. That is the only thing that is going to change in this projectile. Now we are ready to do this question. Okay. So let me show you this question. A particle is projected horizontally with a speed u from the top of an inclined plane at an angle theta with the horizontal. How far from the projection will the particle strike the plane? So this is the question right here. This time we are sending the projectile from the top. Okay, so this is the inclined plane. Okay, this is the inclined plane. From the top of the inclined plane, a ball is thrown in the horizontal direction like this. Okay, it's going to come down like that. You have to find out what is this distance right here. What is this range? What is this range here? Okay, so this time again we are going to slightly change the direction of x and y axis. This is x axis, this is y axis. Okay guys, it's going to change entirely. It's going to, the x and y axis are going to change entirely. Okay, if this is theta, this angle is also going to be theta. Yes or no guys? Parallel lines.
Yes, sir.
Let me show it with a different color. If this is theta, this is given to us as theta, right? Angle theta with the horizontal. This is the inclined plane angle right here. This angle is also going to be theta. If this is theta, can you tell me the components? Tell me the components. One component will be along the x-axis. How much will be that?
U cos theta.
And what is the vertical component?
U sin theta.
U sin theta. So if I make this table, can you help me? What is the velocity along the x-axis? Initial velocity? Minus u cos theta. Do you agree with me? Along the y-axis, the velocity is going to be plus u sin theta. Do you agree with me?
Yes, sir.
Okay. Why minus u cos theta? Because you can see x is towards the right, u cos theta is towards the left. That's why I took a minus sign. Please be wary the fact that we are dealing with vector quantities, so the direction matters to us. Again, I know this is a difficult question, but don't give up yet. You have to get used to solving very difficult questions. Right now, I'm not expecting you guys to, do it on your own, but you should at least understand what I'm doing. Okay, because later on you have to do these kind of questions on your own. So x is displacement along the x is something we need to find out. Displacement along the y is going to be 0. Why? Because if you think about the particle, it goes from the same value of y and it reaches the same value of y. So the displacement along y is again going to be 0. I know people will have doubts here. They will say, sir, see, this is the elevation and this is coming down. So how is y 0? Please understand, y is now no longer in the vertical direction. It is the direction perpendicular to this surface. This is y. So now think, like rotate your head and then think about y. This is some value of y. This is y equals to 0. This is y equals to 1. This is y equals to 2. So if you think about the elevation with respect to this new tilted y-axis, the body went up from the bottom of this y-axis. Okay, sorry, let me use a different color. From here it started, it went up, and then it reached the same y value again. So that means displacement is still 0. Can you tell me how much is the acceleration? Well, the acceleration we have already found out. Along the x-axis, it's minus g sine theta. Along the x-axis, it's minus g cos theta. Now, how do I find out the time? What do I need to find out? S. Okay. So for finding out S, what I need to do is essentially find out time from here. How do I find out time from here? Well, use S equals to ut plus half at square. Okay. So this is going to be how much? U sine theta t, 0 equals to u sine theta t minus half g cos theta t square. Okay, let me move this slightly in. I'm just plugging in the values, guys. U sine theta t minus half g cos theta t square. When you solve this, you're gonna get t equals to u sine 2u sine theta, 2u sine theta divided by g cos theta. Okay, 2u sine theta by g cos theta. That's 2ug tan theta, because sine theta by cos theta is tan theta. After I have found out the time, you have to plug it here. But this time you cannot simply do s equals to ut, but this time because there is acceleration also. So plug in the values with the acceleration. S is going to be minus u cos theta into time, but time is how much? 2u tan theta by g. Okay, plus half of acceleration. How much is acceleration? Minus g cos, minus g sine theta. Right here, it's written right here. Minus g sine theta. T square. T square is how much? 4u square by g square into tan square theta. Okay, so this is my answer. Okay, I know this answer looks very fancy, but when you simplify it, it becomes slightly easier. This is going to be the answer to this question. Please let me know if you understood, if you didn't understand any. Again, don't focus on the answer. Don't focus on the answer. Focus on the process. Did you understand the process? That's the question. Okay, that's the question, whether you understood the process or not. Just moving things slightly up. I'm here. If you have any doubts, you can ask. This particular equation I have written for x-axis right here. And these equations I have written for y-axis right here. So if you have any doubt, you can ask, guys. Okay. Okay, with that, I would like to conclude today's class. In today's class, we have covered the entirety of projectile motion. We have started with very easy questions at the CBSE level right here. And then we have slowly increased the difficulty to JEE mains and up to the JEE advanced level. Okay, so please understand the fact that this is going to become you cannot attempt JEE advanced question just like that. Although I'm showing it to you, please understand, don't get discouraged ki, sir, this is too hard. It's becoming too hard for you because you haven't done enough JEE mains level, enough CBSE level questions. So I'm ending this class with a disclaimer ki, although I have taught you the advanced level question, you are right now in no position to solve JEE advanced level problems. Okay, so you should start doing questions from your modules, and for that I'm going to give you the assignments as well. Do them, and this is the level you can reach. This is the difficulty you can expect at JEE advanced. Okay, so you have to reach this position, but step by step. Okay, so with that, I'd like to conclude today's class. Thank you so much for being here. Okay, and I will see you guys next class. And I'm going to send out assignments as well as notes after this class. Thank you so much, guys.
Thank you, sir. Bye, sir.
Thank you, sir.